Hey everyone. So today for my 50K stream, I'm going to be having back to back to back to back to back to back to back coding interviews. We have a bunch of OGs who subscribe to me. John might be my first sub. So I feel like I was your first sub too on your channel. At least top
No,
10. But
I think you had like 100 subs though to start with, because you had like this machine learning computer vision project back in the day that in Unity you
oh
got some
yeah.
subs off that. So
Yeah, that's true. But yeah, John, Alex, we pretty much from 6 to 9:30 p.m. we got coding interviews and John's the first one. John, how you've been studying algorithms lately, right?
yeah, barely though.
You
Don't
dropped a video on binary search or something.
yeah, but I it was a big L. It was a big
It
L.
was
I
an L.
posted it
You
though.
didn't understand it,
I understand binary search by heart.
really? Okay. So what we have here is CoderPad. If you're not familiar, this is what people use in actual interview settings.
Okay. Yeah, it looks a
Um,
little bit different than last time.
yeah, this is. Yo, appreciate it. Um, Jay, appreciate it. You could run the code as much times as you want. You could see it right here. It's an interactive text editor.
Okay.
So yeah, I'm assuming you only know Python 3, so we're gonna keep it with Python 3, but you could select the different languages there. So
Okay,
I'm gonna
interesting.
post in your first question. You have about 22 minutes to solve it before I kick you off and bring the next guy on.
Okay.
All
Oh
right.
man, I'm about to get folded. Dude, that is that even fair? I got limited.
Okay,
I
we'll
got time
see.
limited. Okay, should I just read it out?
Yeah, read it out loud.
Given an array of integers nums, which is sorted in ascending order, and an integer target, write a function to search target in nums. If target exists, then return its index. Otherwise, return -1. Bro, this is just a basic binary search.
Okay. How do
Like you
you?
want me
Are
to,
you sure?
because it's kind of,
Are you sure? Let's see.
is it? Am I sure? I feel like it. Oh man, now I'm scared. You want it in a function this time, right?
Bro went straight to writing the code.
Yeah, screw it. Okay, basically binary search is so you initiate a pointer on the left side and a pointer on the right side. And then what you do is you look for the middle number. Since it's in
Mm-hmm.
a since it's in ascending order, you check whether or not the middle number is equal to the target. If it's equal to the target, you return that index. Otherwise, if the middle number is less than the target, you would move the pointer here, just one after the middle, and then that's kind of that moves the middle, and then that also moves, and then you kind of search, then you try again, like is the middle number equal to the target? If it's not, um, do the if else statement,
Okay,
right?
makes sense. Go ahead and implement that.
I'll just implement that. Binary search, nums. Uh, so I'll start a P1, a P2, 0. Am I missing something here? Like I feel like you gave me an easy question because I'm
So
your
you
brother
solve
and
it.
stuff.
I can ask an extension if you get it right.
Um,
Okay.
uh,
Okay, I memorized it.
Yeah, I just literally memorized the binary search. Is that what you're supposed to do though? Like, I don't know.
Yeah, pretty much.
Mid is equal to the target. Return mid. Elif target greater than nums mid. Mid equals P1 equals mid.
Ruben, appreciate it.
1.
Akash, what's up? Thanks for hopping on, as always. Overconfidence into bad var naming equals strong, no higher.
Oh man, who's saying that? Who's saying that? Who's saying that?
You're just trolling me.
Watch me get folded by this question though. Was the answer supposed to be -1? No.
What happened here?
I don't even know. Let me see. Target greater. So it's supposed to return output 4.
Yeah.
But it didn't. It output -1. Oh man, I got way too cocky.
Uh-oh.
Man. P1 less than, while P1 less than or equal to P2. Oh man, I got folded by easy.
Debug time.
Not supported between instances of int and list. Length of nums P1. Where is that? Where the heck did I screw that up? Target mid. P1, P2. I know this is correct. While P1 is less than P2, mid is equal to P2 minus P1 divided by 2 if nums mid is equal to the target. Return mid, elif target greater than nums mid. Where the hell is it screwing up, man? Is it screwing up right here? Target. Solution 35 in binary search. Not supported between int and list.
Okay. What's nums mid here? No target?
Nums mid.
There you go. Fix it for you.
What the heck happened though?
There's just a comma. There's a comma here that for some reason Python was behaving weird. Don't worry. I'll let that one slide.
Oh man.
Okay, write some test cases.
Write some test cases. What do you mean?
Write some test cases to make sure that your binary search works. Like test it against what are the edge cases and what are the different cases that you could test against this.
I could test it on. So this one, so in this test case, the target is in there. I'm gonna try one where the target's not in there. It should return -1.
Target's not in there. Okay. What else? What are the other edge cases?
What's another edge case?
Yeah.
What if it's an empty list?
Nice. All right. Okay. We're gonna extend this question. We're gonna extend this question. Okay. So that was a basic binary search. So we're gonna be given a numbers, right? But there can be more than one of the same number. So pretend there's a bunch of 9s here, right? I want you to return me the very first 9, not like you can't just return any 9. Return me the very first 9 in log of n time.
In log of n time.
Like the first instance of it. Return the leftmost. Return the leftmost instance. I don't know how to spell today.
Man. This one's hard. Okay.
Liam, what's up? Let's get it. Mike, how you been? All right, what are you thinking? What's your thought process here?
Do I have to use the same? Like, do I have to use constant space? Because like, if I don't have to use constant space. Like I could just like what I'm thinking is I remove this function. I remove this part of it because like this part of it basically ends the loop.
Huh? Okay. So you're saying we don't want to just return mid because we might just get a random one if that's not the first instance?
Yeah.
Okay, let me ask you one follow-up first. If we said you can do this in O of n time, how would you solve it?
If I were to do it in O of n time, I would just initiate one pointer and then start from the left side. And then if it equals to the target, I just terminate and then return that index. That's basically how I would do it in O of n time. Right?
Okay, makes sense. Okay, how would you solve this in log of n time?
I would somehow have to find, like, I would still use this binary search algorithm, but again, like, yeah. If num's mid is equal to the target, instead of I'll just like set up a like I'm just gonna set up an empty list, right? Target indexes equals an empty list. And if the num's mid is equal to the target, I'm going to get this target indexes and then dot append mid.
Okay.
And then what I'm going to do is, I still return -1 at the end, eh?
If you can't find it, yeah.
Okay. If not nums. What? If nums return no, let's not get into that fast, right?
Yeah, don't worry about the case. Assume it's in there. Not just show me the algorithm. Assume it's in there.
Yeah. Okay. So I'll just like dot append mid, and then let's see what this actually returns though.
Okay, it's gonna infinite loop. I'm pretty sure. Because if it equals, it's just gonna keep equaling. right? And you keep going back into that every single time. This guy breathing loud.
What the hell? Yeah, because what you're saying is like if it hits this, then it doesn't stop. So I'll just
Okay,
do P1 plus equal to 1.
let's think about it real quick like this. We have the left pointer and the right pointer, right? John, look up here. Pretend we capture mid and it's 9. Say 9 is here. What should we do? Like, where should we move the right pointer now?
M minus 1.
We should move it here.
Yeah. Just to check if there's another 9, right? Because you're looking for the lowest 9.
If there is another 9, you move it. You move the right down here.
Yeah.
Or like, what do you do? Or like you do this. Like, just simulate what's gonna happen, and then you'll come to a solution. With the pointers here,
I
simulate
not started coding right away, huh? Yeah. Okay. So let's say right now I'm at the middle of 9. 9 is equal to the target. So I'll move the right pointer to M minus 1, right? And then this one checks for, yeah, num's mid. So let's do P2 is equal to mid minus 1. For now. Let me just put that in there before I forget, right? And then I go back, search for the middle, and then if that's not equal to the target, I'll move the left pointer to P2 plus 1 again. And then it'll search for the middle number, which will be here. And then it's 9, and then it'll check again. And then I guess I return mid after that. So I actually don't need this then. P2. That it? This cascades back.
-1. -1.
What? P2 mid minus 1.
You're close. The logic kind of makes sense. You might be able to finesse it, but
P1, P2. Num's mid is equal to the target, then P2 minus 1. LF target. Right? So what am I doing here? So I'm just gonna pretend I'm a compiler, right? Okay, so I start here. So I find mid right here. So if num's mid is equal to the target, P2, let's just call this P2, and let's call this P1. P2 becomes mid minus 1.
if it's equal to target, okay,
Yeah.
I'll give you one small hit. Like, don't do it -1. It might actually equal that value. Like that.
Right?
If you do a minus, basically it might actually be the result. So if you do like if it's a 9, just move the pointer to the 9.
What? Really?
This actually might be the result. You don't know. Wait, stop that. This is an infinite loop. Right? And then calculate the mid again. Pretend it's this.
Yeah.
Like, if you did -1, it would go here. That's what I'm saying. Just stop it there.
Yeah.
It's like the mid. If the mid is not equal to it, you move it +1. It's like you're close. You just have to play with the conditions. It was like a couple line change.
P2. Okay, let me actually think this through. Okay, so I'm in the middle. Middle is equal to the target. P2 becomes mid -1. So you're saying it should equal to the middle?
Well, because what happens when you do -1? You're excluding that 9 from the search space, right? If you do -1, you're saying that's not part of the search space anymore. But what if that's actually the result? It's not in this case, but
that's actually the result. Yeah, let's make it the result then.
Yeah, like pretend mid was there and you calculated it, right?
Yeah.
9. So if you did -1, it would be wrong, right?
Yeah.
You would exclude it from the search space.
What if I do n mid?
Array append, what's up?
Is that hard coding it? No. Now I'm tripping. Why is this not P1?
I'm gonna set up the next dude. Give me a sec.
Bro.
Gonna set up the next dude.
Okay.
Keep thinking.
No, I'm not getting this one. P1.
Yeah, this might be some. You might have some homework, man.
Like, why couldn't I do my initial answer though? Right? Like if I had indexes.
I mean, yeah, that one might work too.
Dot and mid print target indexes.
Yo, next guy's up, right? Yo, Alex, what's up?
Yo, what's up?
Yo, John, I might have to kick you off now. It's 6:30.
Oh man.
Nice work. Wait, let me pick him up.
Oh dude, Alex, I'm learning Vim.
Nice, man.
Oh man.
What if you just
I'll get to NeoVim one day though.
You know,
Like-
in LeetCode you can set up so it uses NeoVim keys.
I'm experimenting with this one game, but I don't know if I want to pay for it.
What if you stored the result of the index when you found the correct number?
Yeah, that's what I'm thinking. Like, are you talking about my answer here?
Yeah, I just opened it, but I'm guessing I didn't see the
Yeah,
problem.
that's kind of like it's just basically
So like if you had the result set to -1, and then if you found the index that was there, you put, okay, the index is at I, and then you decrement to the left side, and then if you find it again, you update it since a smaller index, right? I think that was the problem. I didn't read the problem, so I don't know. But it seems like it was that.
yeah, I think that's the answer.
Oh wow, James
The
removed
answer
my
is something
background.
like this. I'll modify it. So it's pretty much you just have to calculate the mid. It's like
What? Was my answer not close though?
no, it's more like if the middle is less than equal to the target, you have to remove. We say if the middle. So basically, we have a bunch of nines.
Not in San Francisco. No nines there.
You got doing shots. Alex, how you doing? How's life?
It's
Studying?
cool, man. Elite code is killing me. The meta questions, they're killing me,
God
man.
damn. Okay, I got you today. We're gonna get one in.
I know. Yeah, like the ones I haven't seen, I have a lot of issues with them
Yeah.
because some of them have like special tricks, even the easy ones. Like you can solve them in ON time, but then it's like follow up log n, and you're like, wow,
Yeah.
unless you've seen this before,
Yeah.
just need more exposure, I think.
Okay, let's hop.
Plus, I'm
gonna
like,
give
I'm
you.
trying to run through Hello interview system design as well. There's just so much stuff, man, to
Yeah.
cover.
Okay, Alex, I'm gonna send you the coder pad in here.
All right. Oh, where? On the Discord?
Inside the chat. Inside the chat. Sent it in the chat.
Oh, all right.
John, we're moving on to the next question. Good work though. You solved the binary
Okay.
search, but then you just
And then
couldn't
I
solve
got
the
pulled it
extension.
after.
So
All right,
I'll give you soft no higher.
All right.
Hey, but that's pretty impressive for someone
Yeah,
that's like
that's
not
really impressive.
professionally coding, right? Like that's pretty impressive, dude. Yeah, I
Yeah.
think you're doing a great job.
Okay, thanks, man. All
Are you
right.
going back to learning Vim, John?
No, I'm gonna take a nap and
All
then
right,
hit the
man.
gym.
Do
All
the
right.
Vim tutor. Like in the Vim, you
Oh,
can
Vim
type
Tutor
in
in the
Yeah.
terminal? Yeah,
Yeah.
I'll run that. All right, okay, have fun.
All
All
right. Yeah,
right.
I'm
Peace,
sure I
peace.
will.
Okay, peace.
Alex, you in here?
No, I'm not. I am. Hold on. Where is the Vim? All right. Yeah, I'm here.
Okay, I'm gonna delete. Okay, we're gonna get you I'm gonna ask you a question. We're gonna do this like your regular interview.
Okay. 30 minutes, right? Or less
Yeah, we'll
than.
give you
It's 20,
30.
20, 25 minutes.
Yeah.
It's already
Like, how long does
6:35.
Meta give you? 20 minutes, right? So.
What?
How long does Meta give you? 20 minutes, right?
For
a
one
medium?
problem. Oh,
Yeah.
yeah. Yeah.
So we gotta.
Oh, hell no. What the hell is this? Is this meta tagged?
Yeah, sir.
Jesus Christ. All right. You're given an array of asteroids of integers representing asteroids in a row. The indices of the asteroid in the array represent the relative position in space. For each asteroid, the absolute value represents its size, and the sign represents its direction.
Yeah.
Each asteroid moves at the same speed. Find out. This is meta tagged? Never
Yeah.
seen this
Well,
before.
it's an algorithm that they'll always ask in Meta too.
Oh shit, okay. Find out the state of the asteroid after all the collisions. If two asteroids meet, the smaller one will explode. If both are the same size, both will explode. The two asteroids moving in the same direction will never meet. Oh man, interesting. All right, so example 1. All right, so just kind of a good idea. So plus means moving right. Left means moving left. I'm just gonna make some notes, kind of like description. If you're given asteroids, represent asteroids in a row, and just asteroids and they represent. Oh, the index of the asteroid represents their relative position in space. Okay, absolute value represents the size. Value, size of asteroid. All right, and the sign represents direction. Find out the state of asteroids after all collisions. What do you mean by find out the state? Meaning, like if it
So
like the array shrinks or they get removed, right?
yeah,
Like from
so
the
this is the
output or
output,
something.
right?
Yeah.
Let's walk through this input and output. So why did so these are the asteroids. We have one asteroid moving to the right at size 5, one asteroid at size 10, and then one moving left at size -5. When these two asteroids hit, what happens? The bigger one is going to take over the smaller one.
Yeah,
So
yeah,
that's
yeah.
why we end up with a 10.
All right, interesting.
That makes sense?
Yeah, and since the first two are positive, they're moving to the right direction. They will never collide, right?
Yeah, they'll
They will
never
never move.
collide. But okay, what if we have -5 right here?
If we had -5,
What's the output?
So that's another thing. Do we start from the left? We check maybe. Oops, shit. So basically, if I started from the left and I saw two are positive, they're not meeting, then I'm checking those two. This one is bigger, so this one collides.
Then what happens?
Then they will collide as well. So the output will be 5 and 10 still.
Yeah, yeah.
Is that
Because
correct?
-5 collides with this one, it basically disappears. And -5 will hit this one and disappears. Okay, what
Yeah.
if we had something like this? What should be the output?
So the first one, nothing happens. The next one, they collide, so they both disappear. Then it becomes this, and they collide again. It becomes empty. Is that correct?
Yeah.
Hmm.
Now take a look at example 3. How's that look? Or like, can you simulate that and see how this works?
Yeah. So in example 3, so 10 and 2, nothing happens. Then 2 and -5, they collide. So -5 wins, and then 10 and -5 collide, and 10 wins. Right?
Yeah.
Yeah, it says output 10, right? Yeah.
Okay. Yeah, you understand the problem. So what are you thinking?
Well, so I'm thinking we probably shouldn't be doing this in line, since there's going to be a lot of like array manipulation and comparison. Because every time we like remove a number from the list, we pretty much have to go through the whole array, right? Like n times.
Yeah.
So that's not a good idea. What am I thinking? Another thing, what I'm thinking is maybe there's some kind of data structure we can use, such as a stack or a heap. So let's say, let me see. So for example, if we push 5 on the stack, well, let me do it with some simple example. So for example, if I'm just going through, well, let me do it with this example. 1 second. So let's say if I'm going through the whole array and I push like 10 on the stack, then I go and let's see. All right. So let's say we're at 10, right? First number, we push it on the stack. Then we go to the next one. we also push that on the stack. And then we know, so we can compare the top of the stack if it's positive versus the current number, right? So then if -5, and we check that the previous number is opposite, like it's positive, and this one is negative, we compare their values, and based on that value, so that's going to be interesting. There could be two cases here, right? So if -5 is bigger than 2, then what we do is we pop it and remove it, and then maybe we can have a while loop while the stack is still full, and we compare it with the 10, and then if 10 wins, we just move the index to the next one. That's what I'm thinking. And if it was like -20 here, we would pop the 10 and put the -20 on the stack, and then move on to the next one. Does that seem like it would work?
I think so. Let's run it on one case right here, or like write a bigger test case, like
All right.
10, 5.
I guess.
5.
So I guess what I was thinking is kind of like, I think it's called like monolithic stack maybe, or something like that. But all right, let's. All right. So let's try this.
Just let me know what all the conditions you're talking about. Like, how would this work?
All right. So basically the condition would be starting from we have length at least 2, so I don't need to check for empty list. So the first number, if it's negative or positive, I would push it on the stack, right? So 10. So then I would check is one of the conditions would be, is the number bigger than 0 or smaller than 0, right? So if it's bigger than 0, we check the stack. Is the stack bigger than 0 or not? If they're the same, that means that, hey, like this goes on the stack, right? Then, like, so it's a check. Do they collide or not? So then what we do is we check, is -5 and 5, they're different, so they collide. So the condition would be, if they're equal in absolute value, I move on, but I also remove this one, right? Then that's the same number.
What if
I
it's
add.
bigger? What if
it's
6 here? What happened there?
If it's what?
6.
Oh,
there
if it's
instead.
6, so then the condition would be, okay, 6 is bigger, so we move on to the right, because it destroys it.
Okay. What if it's 4?
If it's 4, then it would be 4 in the stack. We remove the 4, and then we check, is the stack full or not? And if the stack is full, we continue to compare while the stack is full. So if -5 is smaller than 10 in absolute range, so it gets destroyed, and we move on to the next one.
Nice. Okay, makes sense. Go ahead and implement that.
All right. Daf. What do we call this? Let's say asteroid check, and then we're given a list. Asteroids. So this would be our stack, and then basically I would start from index 0, get the size of the asteroids, and then while index is less than n, so let's go through and process the stack. So we pick out our first item, which would be asteroids in the index, right? So first we check if stack length is greater than 0, or like we can just say stack. If stack, that means there's items, right?
Yeah.
If the stack is there, we need to do like a comparison. So maybe I can either compare it here or write another function which compares the two. Compare to asteroids, right? What I want. Let's name it a little bit better so people don't say S. So if stack, right? So what we can do is basically compare to asteroids, and then actually let me think. So basically what I need to do, let's say, let me use this here. I'm going to copy this to here, just so I can visually see it. So if we have a 10 here, let's start with if well, I'll come back to this condition, but 1 second. So we'll push this on the stack. If it's empty, and then we'll move on here. Say, need to move all of this forward. Okay. So let's do the condition where there's 2 asteroids. So let's say we went through here. We appended 10 to a stack. So we have 10 over here in the stack, right? Then we increment that index. So the next item will be the next item will be 2, right? So then we compare. So that's where we need to compare, basically, right? So if so, that's an interesting one. So if item is greater than 0 and stack -1 is less than 0, or so it could be 2 conditions, right? We could have a positive number on the stack and we encounter a negative number in the list, or vice versa. That's what I'm thinking. Or item less than. Can we have a item? Okay, asteroid cannot equal to 0. It says in
Yeah,
constraints.
it cannot
right?
be equal to 0.
Okay, because I'm like, maybe that's a getcha right there. Okay, cool. And then items greater than 0. So this is the case that, 2 asteroids going to different directions, right? So in that case, now we need to compare the absolute values. However, I'm kind of seeing an issue with this already where I'm not tracking which one is on the stack. So maybe it'll be, yeah, I think I need to know the difference, which one is a negative and which one is not. So it's going to be else if condition. Right? I think, yeah. Right.
Yeah,
So
maybe to simplify this, we can have 2 conditions. Like, if item is negative, like just have
okay.
all the conditions. If item is positive, and then break it out into the cases.
Okay. Okay. Yeah, that makes sense. Then else if item is negative, and it's not what I just did though, but okay. And then item is less than 0, and then item is less than 0, and stack is... And then I guess if they're both equal, right, then
Yeah.
So that's the kind of if they're both negative or both positive, I'll push it on the stack. Okay, so if the item is bigger than 0 and then the stack item at the end is less than 0, we need to see well, it's gonna be a repetitive kind of condition, but it's okay. So we need to see which one is bigger, right? So we could do if item is bigger than... I can refactor these conditions because I see there's going to be a lot of the same ones, but to make it more... So get the absolute from both of them. So if the item is bigger than the absolute one, so we need to destroy that item, and we need to destroy that item.
Yep.
But we need to keep going if it so maybe this should be a while item is greater than 0 and stack is... We need to keep going then, because basically if I pop that item, there might be another item. If the stack is valid, if there's still stack, we need to still pop the other item too.
Mm-hmm.
And then on top of that, yeah. So okay, so we need to pop that stack. Let me see. Hold on. So if you have an item, we pop it, but then if we destroyed all the items on the stack, we need to push that negative to keep track of it as well. Maybe that's where I messed up. But anyways, let's see. So that's what I was thinking. So let's say this was like 20, right? And then there's a 5. So let's say on the stack I had a 10, then I had a 2. Then we encounter 20, we destroy the 2. We need to destroy the 20, the 10, and then we need to put the minus 20 on the stack. Stack will have the final result. So maybe while item is greater than 0, while stack and we'll pop it, and then at the end, since that item 1, we need to push it on the stack. That's what I'm thinking. Yeah, there's probably a better way to do all this if-else cases with just one absolute function, but I'm kind of running out of time, so I better not worry about that right now. All right, so, and then the same thing, I think, would be here, right, except... while stack is... While stack and absolute item is greater than 0. But what if... Man, hold on one second. Gotta cut off
Getting
the
close.
I know. Okay, so while stack and absolute item is greater than absolute stack, so we have an item that's higher than what's on the stack, you pop it, and then I'm just thinking of some test cases that where if we pop the minus 20, we appended it, And then what's next? Okay, then we go to the next item. That makes sense, I think. But then, okay. Yeah, I think that makes sense. Now, in the case of item minus the 0, I mean, this is the same condition. I feel like I can just, because if you're doing absolute check anyway, why can't I just do this? Oh,
Yeah.
right, it's the same thing, I think. Right?
Yeah, probably there's a way to simplify it.
Yeah. Let me run through this because there's a lot
Yeah.
of different
Do a
conditions
dry
here.
run. Do a dry run real quick.
Yeah. All right. So we
I'll
start.
be right back. Give me 30 seconds. Just dry run it while.
All right. So item is 10. Stack is empty. So then our stack. Oh, what happened to my stack here? Oh, I totally messed everything up here. I bet. How do I move this? The indent hella messed me up because I wrote that compare function and I decided not to use it, and then my whole indent messed up. Damn it. All right. No wonder there's like all this underlines and everything. Anyway, so stack is 10, index is 0. Then we go to the next one. Index will be index will be 1. Man, that's too. All right, so then index will be 1 here. So this will be 2. So we push 2 on the stack. And index becomes 2, which is minus 20. So this is minus 20. So now we're comparing, is item 0 more than 0 and stack less than 0? Correct. It is. This is what happens when you do lead code for 5 hours. But anyways, well, stack, yeah, we have something on the stack, and then the absolute item is greater than absolute stack minus 0, which it is. 20 is greater than 2. We pop it, and then we compare again. We pop that, and then we append the 20. We append the minus 20. Okay. Then we go to the next index, which is 3. Here will be 5. So if his item is bigger than 0 and the stack is less than 0, yes, it is. While stack and absolute item is greater, then we pop, but it's not. But I still append the item, which is a mistake. So this is the condition I need to update. Basically, the condition right now I found that's a fault is basically if our item is 5, but my stack is minus 20, I skip it, but then I append the item, which is a mistake. I'm not supposed to append it. Wow. So maybe I can check another if else here. Oh, I'm trying. think about the case.
Wait, I'll give you a small hint. Why not just do something like, or what, or like it's confusing here. Why not just like remove this right here? Wow. This. Like while the stack. Wait, let me bring it back. Cause you have like this extra thing, right? Like why not just do like while that stack is there, and this, and you know what I mean? Like just have the while loop all the way at the outside. So
yeah, that's what I should
something
have
like
done.
this. It might be simpler if you do that.
Yeah. That's what I should have done. Yes, that's the monolith stack thing. But yeah. The only concern though, like if let's say the item minus 20 wins here, we append the item here, which is we shouldn't be doing that. We should be moving forward, right? Because
yeah, maybe you could just track that final case somewhere, but
yeah, if
we got our next person in, Alex.
Damn.
That was a good run though.
Yeah.
You got the solution. It was literally just more about get like implementing it.
Yeah.
But
I need to work on that more. But it is what it is.
All right.
Yeah, basically
thanks.
I could do the last if else statement to check if the item is smaller on the in the list, and then just
John said
continue.
up the limits, but this is how fast you get an interview these days.
Yeah. It's very fast, but yeah. I like if I did more run throughs, I would have updated it more, but it is what it is because we started at 6:35. But it's an interesting question. I never seen it before, so that was good for me to. But yeah,
Cool
good stuff, man. Thanks for having
me.
me.
All right, thanks, Alex.
Yep.
Get some sleep, man. Get some sleep.
All right.
All right.
Bye.
See ya. Yo, what's up? Wait, I can't hear you.
Yo, hello.
Yo, what's up, man? How you doing?
I'm good. How are you?
I'm good. How you been?
I'm good. I was doing my discrete homework until
you're doing
I
discrete
remember
math
that.
right now?
What?
You're doing discrete math right now?
Yeah.
That's rough. Let's see.
Okay,
Yeah,
I think I only have time for one problem.
Yeah. Let me take off this. Wait, yeah, for sure. You only have 30 minutes, right? Let's see.
Yeah. Okay.
Wait, can you say something?
Yeah, hello?
Yo, chat, can you hear him, right? Let me see. Let me test audio. Let me test audio real quick. Yo, can you say something?
Yeah, hello?
Sick.
Well, Loki, I haven't done leak code since I got an offer. So
Nice.
really
How you feeling
frustrated.
about the offer and stuff? It's good? You're happy?
Yeah, I feel really grateful. Yeah.
Yeah. Good for you, man. Good for you. Were those training sessions helpful? Can you hear me? Oh, he left. He's coming back.
Oh shit, I accidentally closed the
Okay.
tab.
I'm gonna
The
send
training
you the
sessions were-
question.
Training sessions were helpful, yeah.
I'm gonna send you the question. You got this one.
I've done a lot of things. I've replaced my smoke alarm. I got better at. No, I got worse at leak code. Yeah, I replaced my smoke alarm.
You replaced the smoke alarm? Okay. Now you need to go up on CJ's stream again and redeem yourself on the smoke alarm.
Yeah.
You ever think you're gonna hop back on the stream?
Am I ever gonna hop? Well, I don't know. Wait, that wasn't even me though. That wasn't me. We know that.
That's true. Yo, okay, read this. You get this one?
Wait, low key, I might be stupid.
Why?
Wait, 'cause I'm so locked out. I have no idea what this is saying. Okay, wait. Sorry, and gas station looks like the amount of gas it has. It costs.
So we're pretty much given a circular route of gas stations.
Yeah. I got it. I get it. Yeah.
Okay, I'll let you go.
Return to starting gas stations index if you can travel around the circuit once in a clockwise direction. I'll return -1. If there exists a solution, it's guaranteed to be. Okay, so we're given gas and we're given cost. Okay, the amount of gas at the I station. Okay, so the amount of gas in, let's say the 0 station
Yeah.
costs. I see, and we travel counter. Wait, we travel. We travel clockwise. So left to right, right? Yeah.
Yep.
Left to right, and then we loop back around. It's like if you start at 3, actually 2. I mean, if you start at 2, then we go right, and then we loop back around, sort of, and we come back to 3. Right? Is that what the question means?
Yeah.
Okay. And we're always going in a linear fashion, right? So if you start at, we can't ever skip stations. So if I start at station 2, right here, then I can only ever go to the next station, right? I can't skip. Is that correct?
Mm-hmm.
Okay. Okay. And so just like clarify, the cost of going from the second index to the the second index to the third index is 5, right? Not 1.
Going from this
3
one.
going from this one 3 to 4 is going to cost 5, right?
Yeah.
Not 1. Okay.
Yeah.
Okay. And here they explain why this is so. Okay, so is there can there be more than one solution?
If there exists a solution, it's guaranteed to be unique.
Oh yeah, my bad. I forgot how to read. Okay. Starting gas station index. Okay. All right. So let me see the second example where there doesn't exist a solution. You can't start at 0 or 1. There is not enough gas station. Okay. See, this gives me a pretty big hint as to like maybe a naive solution. I think in the naive solution, what I might do is I might go through our array of gas and keep going until I find an index that has enough gas to make it to the next one. So, for example, they say here that we can't start at station 0, 1 because there's not enough gas to travel to the next station.
Yep.
We have unlimited gas. And it costs the amount of gas. Wait, if you have unlimited gas, why do we get more gas?
No, you have unlimited. You have an unlimited gas tank. That means you can just keep filling it up.
Oh. Right, I actually can't read.
No worries.
Cost. Okay, so yeah, we have a limited gas tank, and so yeah, the reason why we can't make this trip is because at the first index we load up 2 gallons of gas, but it costs 3 to travel, right? So we skip over that. Next one, 3. Oh yeah, so we don't even consider that. And then okay, let's go to station 1, index 1. We get 3 gallons of gas, but it costs 4, so it's impossible. And we keep going, and then here, when we arrive at 4, we see that okay, this is possible. So we start here, and then we have enough gas, right? We'll have 1 gas left over. And then what I'm thinking here is we do that logic that I just described where you keep comparing the gas index to the cost index. And if the gas index is lower than the cost index, then you know that that's not even a path that you can consider, right?
Sure.
But on the first time you find something that is possible, right, where the gas is greater than or equal to the cost, then you start considering that. And so you might have like an inner loop where, you might have an inner loop where you basically start at that position, and then you probably have some logic with modulo where you can wrap around the whole length of it until some sort of counter reaches the position that you started at. So like I'm describing a lot, so I think I should probably put it into paper.
Yeah, go ahead.
So,
Write some stuff down.
so here's like what I think about the naive solution. So naive. Keep iterating. Keep iterating over array until we find I such that gas I is greater than or equal to cost I, right? And so once we do, or actually I could probably say I could probably say when it doesn't, when you make a full pass without this condition, return -1. So that, okay, when the condition is true, here's what we do. We can probably have some sort of index set equal to that I. And then we can maybe say while index modulo n, where n is length of the array. While index modulo n, where n is length of the array. Let's see, while index n.
So what are we thinking? Like, just find a place we can start and try to simulate it. If
Yeah,
it doesn't work,
exactly.
move on to the next one.
Yeah, find a place we can start and then try to simulate it by having a pointer and then wrapping it around using like modulo. And the way we know within that loop, within that simulation, whether or not it's possible is through like maybe a running tally of the amount of gas we have. So like gas tank, we set it equal to gas I. And then, while gas tank is greater than 0 as well. And then here it's pretty easy to say like, okay, when gas tank, if at the end of this loop, if index isn't at where we started, I say where we started, like it's not going to be exactly where we started because we have like modulo, but like considering that wrapping around functionality, like if the index isn't at where we started, then we keep going, right? Going back to this, keep trying to find a starting path. But if it is, then that's the unique solution. And we return I. Does that make sense?
Yeah.
Do you think I should implement this simulation?
Okay, you're gonna implement what's the runtime of your simulation?
Yeah, so checking for a starting point is going to be O of n. And yeah, checking for a starting point, like there can be maybe n different starting points. And let's say all those starting points seemed valid to us, right? So that would be O of n. And then let's say in the worst case for each of them, we have to go in a loop just to find out that we don't have enough gas to make the full trip, right? So we stop just short of it. Then I think it's going to be n squared runtime, just because we have to make n squared operations. We loop over it once, but then for each singular element in the array, we have to loop over the entirety of the array one more time again as well. So that's like n squared.
Is there any faster?
Well, there probably is a
n
faster
squared
way.
Yeah, right now it's n squared.
Yeah, right now it's n squared. I'm noticing there's probably a pattern to do. There's probably some sort of pattern in the way we, because just to walk you through like an example, like if you go to example 1, let's say, if you go to example 1, then there's probably some reused logic where if you know that you can make the trip from station 1 to station 2, your call ends in 15 minutes. Okay, but if you know that you can make a trip from station 1 to station 2, and you can make this trip from station 2 to station 3, then there's probably some logic that you can reuse without having to go over the full length of the array every single time. I think finding that pattern is probably going to be the hard part.
Mm-hmm.
Let me think. Could there this almost reminds me of like a gas problem, not gas problem, like what's it called, a graph problem, where these are like different nodes, like these are different gas stations, and there's like a weighted edge between each of them. The graph structure wouldn't make much sense because that's just like almost like a linear graph, which isn't really a graph. It's like a linked list.
Yeah, we have like a linear data structure already.
Sorry?
Like we already have a linear data structure, so there's no point in turning it into a graph, right? Like it's already in an array, and we're only looking to the right.
Yeah. So yeah, a graph wouldn't be appropriate. Yeah, I'm not gonna lie, I have no idea.
Okay, try implementing the O of n squared solution, and let's optimize.
Okay. Should I just name it any function?
Yeah.
Okay. So if we only have one gas station, then that trip is always going to be possible. So I think we can just return 0 in that case, because that's an index. Yeah, but otherwise, what did I say here? Keep iterating over the array until we find I. So let's go, let's see. For I in range n, let's say if gas I is less than cost I, then we're going to continue. Yep, but otherwise we have a nested loop here. So we can say gas tank is equal to gas I. Yeah, gas tank is equal to gas I. And then we can say here for k in range. Let me think about what we want to do. We want to somehow arrive from I back to I. So that would be I plus the length of the array, basically, modulo n. There might be like an off by one error there. I'll probably just I for k in range I plus n. Let me think about it with like a small input. In example 1, they gave 5 such numbers. So if you started at 2 or index 2, then 2 plus 5 would give you 7. What's 7 modulo 5? It's 2. So yeah, I think I plus n modulo n probably work. Okay. And what are we going to do here? We're going to see if our gas tank is like cooked, so if it's like less than or equal to 0, then we want to break out of this loop. Oh, we probably have a flag here too, like flag, like solution found is equal to false.
Your keyboard sounds nice.
Sorry. Oh, that's like my laptop keyboard.
Oh.
Solution found. Then we're gonna return I. That's if gas tank less than or equal to 0. Wait, actually, solution found should be set to true. And then we can set equal to false here. Okay, but otherwise, what we're gonna do, we are going to Wait, we should probably start from I. Yep, I. Okay, so what we're going to do, we want to subtract the current cost. So, actually, let's make it start from the next one.
Why not just go something like for I and N right there and just calculate. Go like I plus K mod N.
Yeah, that makes more sense, yeah. Okay, so you want to just subtract. Yeah, it's pretty simple. We just subtract it by the current cost. See, does that encompass everything? Wait, next index. Yeah, gas tank minus next index. Yeah, I think the logic here makes sense to me. The implementation might be slightly off. If we have 1, 2, 3, 4, 5 earlier, 3, 4, 5, 1, 2. Yeah, 1, 2, 3, 4, 5, 3, 4, 5, 1, 2. Then yeah, so we start at 3. Yep. Wait. Zero, 1, 2, 3. Oh, 4. Okay. You start at 4. 1. Okay, should we just run it actually with this input?
Yeah, run it. Run out some cases.
Yeah. Actually, move it to the bottom. So if you have gas 1, 2, 3, 4, 5, and you have cost equals 3, 4, 5, 1, 2, and we try to do print solve gas cost, what would we get? List index out of range, I plus k. See, I plus k modulo n. Why would this? Wait, why would this be out of range? Should it be parenthesized? Yeah, okay, that fixed that error. Otherwise we should return. But I know this. Okay, so my implementation is kind of wrong because we know for a fact that this has a solution. So why would this be wrong? 4k in range n, I plus k modulo n. Minus cost next index. Keep going, I plus k. Wait, what's wrong here? Why would it be returning negative 1? 1, 2, 3, 4, 5, 3, 4, 5, 1, 2. Let's see, gas tank. Oh, wait. I don't think we want to go n times, right? Because if you start at 4, we don't really want to recompute 4. That wouldn't make much sense. So
yeah, minus 1 or something.
N minus 1. Okay, that still didn't work. Let's run 4. Let's see, 1, 2, 3, 4. Yeah. Actually, it should be if the gas tank is negative, not so much so.
Yeah, like if we got to it right at 0, we're good.
Yeah. Would that fix it though? Yeah, I think
Okay, let me read
something much more systemic here. Because bro, I'd rather have a I'd rather have a graph problem than this. So confusing. I'm so
It's array. Okay, let's look at for I and range. Okay, walk me
Yeah.
through line by line.
Yeah, okay, that'll probably help. So here what we're doing is we're just looking for starting candidates, right? Over the entire
Yeah,
length of gas. And so here gas I is less than cost I. What we're doing is we're checking if there's even a possible candidate. And so if the gas
sure.
is less than the cost, then there's no way that we can ever consider that as a starting position.
If the gas is less than
Otherwise,
equal to, I think.
wait, really? No,
Right.
I don't, because if you're at station 3 and you have, let's say you're at this station and you have wait, what does this mean again?
Wait,
Wait,
if
what
the
is
gas
cost? Cost is like this is how
like
much
gas
gas you're
is
getting, right?
yeah. So if you could capture enough gas, okay. If the amount of gas is less than the cost, okay. Yeah, you're right. You're right.
Yeah. So you can have just enough gas to make it to the next station.
Yeah.
Okay. Okay, so we found a candidate, and so we have K, and we want to go up until we want to go clockwise, basically. And so this n minus one means we want to go the length of the array
Uh huh.
until we reach the element right before. So if you have like this is a array of size 5, right? So we want to go 4 positions, so 1, 2, 3, 4, and that'll arrive at like the last iteration of the loop is going to be 3. So the element right before the current element is what this
Sure.
line achieves. And these 2 lines are good probably. Okay.
Is it
Now
okay? What's
here's
I plus k in the first iteration?
I plus k. It's going to be 0, right? So 0 modulo n. Wait, no, it's not going to be 0. It's just going to be I, right? I modulo n, which is just going to be I.
Yeah. Yeah.
So that should be fine, right?
Okay.
Because here we still haven't subtracted the cost to get to the next station. So I think we want to
Sure.
include the current element. We want
Okay.
to include I too, right?
Mm-hmm. And then
So we started the gas tank and we just want to keep going. Oh, wait. And then we want to refill it. Yeah, that's the thing. We never refill the gas tank. I don't know how I didn't catch that. We probably do something like gas tank. Wait. Gas tank. Gas tank plus equal gas next index. That'll include the current element. Yep, so gas tank plus equals gas of the current element.
yeah.
And we subtract it, and then we can move this logic over here, right? If it's less than 0, but then we didn't find the real solution. So I'm gonna run it.
Nice.
Yeah, okay, and that gives the correct answer. So this is, like I said, O of n squared. I don't think I'm gonna get to the
Yeah.
actual
No problem.
optimal solution today, but
Yeah.
it's a good mental exercise. I haven't done this in a while.
Yeah.
good to-
Thanks for this might kick you out in like 1 minute, so thanks for hopping in. That was still good enough, I think.
Really? Wait, actually, I don't think it was good enough, really, to be honest.
I mean, yeah, it depends on the role. Maybe for like a, I don't know. It depends. It depends on how the other candidates do. If other candidates couldn't do it, like you still got a
Okay,
solution. So
is this a greedy problem?
it's a greedy problem. Yeah, you could do it in over.
Oh, yeah, that explains because I don't really get greedy problems.
Oh, okay. All right.
All right,
Thanks for hopping in, bro. I have to jump to the
Alright.
next guy.
all right. See ya.
Appreciate it. See ya. Alpha's. Yo, Paul, what's up?
Yo, what's up?
How you doing?
Hold up, I gotta view your stream real quick. Alright. I'm doing alright, I bet you.
I'm chilling. You ready for some math?
We'll see. It's probably hit or miss, I imagine.
Okay, I got the question loaded up. I'm gonna run it right away to save you as much time as possible.
I'm gonna try to use Vim.
On here?
Yeah,
You got motivated by that Code Forces guy, huh?
Dude. I mean, I've been using Vim at work, but like,
Oh, really?
yeah.
Alright, this is the question. For fun, you're just doing it at work?
Yeah, I've been using it at work just so I can like, I don't know, just get better at it. I think I've done.
Damn, Fahim was using it too.
I think I've done this problem before, but it was like years ago. I'm pretty sure. All right. So,
Fine.
what I'm thinking here. So we want to return the number of ways you can write n as the sum of consecutive positive integers.
Oh shit, you deleted. Your Vim key bindings are tweaking.
I didn't do that.
Okay, good. Oh, okay, good. So what are you thinking? What's the thought process?
Just give me like just a second here. I'm just thinking about if this method I have will work, because if not, it's not going to make sense. So what I'm thinking, right, is the way it works is that effectively there are two different like things here, right? So you either have like, so you have n is odd, or you have, what would you do? I think you'd, I don't think that actually works. So I think, oh wait, actually I think this does work. So what you want to do effectively is you just want to so this constraint here, okay, it's kind of cheating, but it makes me think that maybe I think you just want to keep recursively dividing by 2 until you have, so I'm gonna just write this down, recursively divide by 2 until you have an odd number. No, I can't type. And then after that, what you want to do is you effectively want to, okay, well obviously like your result is going to start at 1, so the minimum you can have is 1, because obviously like if say like base case just you have 1 and equal 1, then it would just be 1, right? I assume, does this, I don't know if this counts or not. Does this count? So if you have n equal 1, I guess would the result be 1 or 0? Or do you know?
If you have 1, what's the result?
Yeah. So yeah, if you have 1, would the result be 1 or 0?
Let me test. I actually don't know. Probably. Let's see.
I'm just I think I can assume here.
Expected is 1. Yeah.
Okay. That makes sense. Okay, that makes a lot more sense now. I was thinking it was 0, and I was thinking like.
Well, it's consecutive positive numbers.
Yes, yeah. So like the result would just be 1, if you had n equal 1, right? So
number of ways you can write n is the sum of consecutive positive integers, so it wouldn't be like 0, as it'd just be 1. So what you want to do is you just want to keep recursively dividing by 2 until you have an odd number. And then after you do that, you want to you effectively want to check if that odd number squared is less than or equal to n. So effectively what we're doing here is we're just going to like find the square root effectively. And the reason we're doing it this way is because each time, like for every integer below the square root, so say we have like 5 here or 15 here, right?
Mm-hmm.
Effectively, each time you can do this, you have like it's effectively like squaring it. So say you have 1 and then 3. So your result for 1 is 1, and then your result for 3 is that's 2 though. I'm not sure if that works. Okay, actually, yeah. Okay, this does work. So I think
Let's
what
just
we
do a
want to
small example. Let's start off with like 5.
Yeah, so I don't think the algorithm I was mentioning works in the way I was describing it. So I think like what we want to do is we just want to check all the odd numbers, just all the odd numbers in general. So we're just going to call these, I guess we can just call them k. I'll just call them i's because I'm going to index it as I. So we're going to check basically if n modulo I equals 0. So like if n is divisible by this each odd number, right? And then we're going to like calculate, or I guess just check the count of these factors odd only. So we're going to check the number of odd factors, right? And then for each odd factor, we're going to multiply by the count. So for example, here, we'll do this 5 example. We'll start with, so the 3 odd numbers we're going to be checking here are 1, 3, and 5, right? So we're going to start with res equal 1. And the reason it's multiplicative is because of just the way that's, like the way that permutations work. So each time we're multiplying by a new permutation because it can be any permutation of these numbers, right? It doesn't have to be in the particular order. So we don't have to divide by 2 either at the end. At least, I mean, maybe, I don't think so though. So we have 1. So 1 is divisible by 5. So count equal 1. Well, count initialize is 0. The binds are not working on this. So we have 1 through 5. We're going to start at 1. So count equals 1 because 5 is divisible by 1, right? So pretty much for every number, it's going to start with a count of 1, but we're just going to initialize to 0 just for the loop. And then res is going to be multiplied by count. So res still equals 1 because we're multiplying by 1. And then we have 3 here, right? So effectively, the count doesn't go up, but we're still going to multiply, right? I think. No, I think we initialize. Yeah, I think we initialize count. Yeah, I think we initialize count as 0 for each of these numbers, just to check. So we have count equals 0 again. And then we're going to Okay, we're not going to multiply by count. Don't think. I think we want to multiply. I don't think we want to check 1 here because 1 is always going to give us a result and we don't necessarily want that.
Sure.
So we want to only check odd integers 3 or above. So we're going to check all the odd integers from 3 to 5. And we're going to set count equal to 0 for each of them. So we're going to start count equals 0 here. And then we're going to iterate, or we're going to check, I guess, how many times it's divisible. So say we have, I mean, that'll make sense in a larger example, but in this example, so 5 is not divisible by 3. So count is still equal to 0. And just so we're not multiplying res by 0, we're going to multiply by count plus 1. I think that should work with the way I'm doing it, because I'm not counting 1. Because we don't.
Okay, I'll give you a
really
small
want-
hint. I'm not sure if this is going the right direction so far, but like,
Okay.
you know what integer factorization is?
Yeah, that's like kind of what I'm doing. I think this should have log in basically runtime. I don't know if that's faster than factorization. I think that what I'm doing will work though. I'm like
Oh wait, can you
95%.
explain it again?
Yeah, so effectively, like what I'm doing is for each of these factors, like I'm not really doing the prime factorization of it, but I'm checking each odd integer for possible factors. And then for each factor, I'm going to get basically if it can divide into it, and then I'm going to add those to the possible permutations by multiplying the res by the number of permutations that are available within that, if that makes sense.
Mm-hmm.
So I think I'll try this way. If it doesn't work, I'll try just straight factorization. But I think that what I'm doing should work, and I think it's better runtime, but I'm not sure on that.
The best solutions are O squared to the n.
Yeah, okay, yeah, that's what I'm doing as well. I'll just try this for like a second. If it doesn't work, I'll try something else.
Okay.
So I think what I do here is, now that I have count plus 1, basically res is going to stay at 1 for 5. And then once I get to 5, I'm going to check it for all. So I'm going to see, okay, so basically this, actually, I'm just going to do a bigger example. I think it's easier to explain the bigger example. So I'm going to do 9. So I have 1, 3, 5, 7, 9. And I'm only checking ones that are beneath or equal to the square root of n. So in this example, I'm only going to be checking 3. What was that? Okay, that's weird. So effectively, I'm just going to go into this at 3, and I'm going to initialize count as 0, and then I'm going to say for each time that I can divide n by this, then I'm going to increase my count. So count plus 1, and then I'm going to have 3. So I'm just going to say n equal 9, but now n equals 3 because I've divided it by 3. 3 also goes into this now. So now it's going to count equal 2 because I can divide it again. So now n equals 1. Yeah. So after I do that, I'll have count equal 2. And then I will do res equals 1 times count plus 1. And that will give me 3. And basically at the end, if res equals 1, I can just return res squared. Because like I'm not at this point, I'm not counting permutations. I'm only counting up to the square root. But basically, any permutations are going to get squared whenever you start adding like if you square the number, if that makes sense. So that's why it's O of square root n, I believe. Does that algorithm make sense at all?
I don't get the solution, but you might be in the right path.
I'll try it. I'm just gonna def.
Here, I'm gonna send you a link in the chat.
Okay.
So you can just run it straight on Decode.
Okay. Oh, you send it on here. Okay. Okay, so like I said, I'm just going to set the result equal to 1. And then I'm just going to effectively find the largest or the first odd factor until I keep going. I'm just going to keep dividing by 2 until I get an odd number. So yeah, this is like effectively the prime factorization part that it's like talking about. So you just because you keep getting 2 to get all the evens out, and then you just get only odd numbers, and then all of these even numbers will effectively balance out when you square it. If that makes sense.
Mm-hmm.
So I'm just gonna say while I squared. I haven't initialized I. I think I'm just gonna start at 3. Okay, I'm just gonna make this make sense. Modulo equal 3 because I want it like the number to actually make sense what it's doing. So while modulo squared, I don't know if I use less than or equal to here. I think I do equal because I want to count 9 as well in that one case. I want to count 3 squared less than, yeah, so I would want to do less than or equal to here. And for each of these, I'm going to initialize count as 0. Or I guess I could do count equals 1. Yeah, I'm going to do that. I'm just going to do count equals 1. And then I'm going to effectively modulo equals, so for each time it can divide into it, I'm going to obviously sorry, I'm gonna divide by the modulo because I'm finding the number of times that it goes into this number, so I need to keep dividing by it, and then I'm gonna increment my count, and then at the end here I'm gonna multiply my result by the count. Yeah, I think this should work because everything can go into 1. So I'm effectively just like by doing 3 here, I'm effectively making sure like everything can obviously go into 1 because 1 is, anything can divide by 1 if it's an integer. So all of these counts will start at 1 just to effectively skip 1 because it can cause some like runtime errors, or it can cause some. I'm pretty sure it'll cause an edge case to fail. I'm like 100% sure it'll cause an edge case to fail if you try to start at 1 here. So yeah, and then modulo. So I'm gonna go up by 2 because I'm counting the odd. I'm checking the odd numbers. I guess I could just odd. I don't know if that is a better variable. So I'm just gonna return res squared, and I'm pretty sure this will work. Okay, that gave me the wrong answer. So 5, it's giving me 1. So it's okay. So it's not counting it's like skipping 1 effectively. So I think I do actually need to do this. What I was thinking before. Start at 0 and then multiply by count plus 1. I don't know. I think this should work. Oh wait, can I not?
Can you know what? Run it?
No, I think. Can I not just change the variable that's passed in? It's not. It seems like it's not working. But maybe I'm just doing something wrong.
You can. Like,
Let
if you
me
print
just-
end there.
Yeah, let me try that. Okay, well these are all of the test cases are odd, so that's not really helpful. But that means something in this logic is wrong then, this while loop. So I think while odd squared less than or equal to n, count equals 0, while n modulo odd equals 0, divide by the odd and increment the count, yeah, and then multiply by count plus 1 and increment odd. I think I'd multiply it by 2 because effectively any even numbers are going to double my results. So I think if I just do this should work. Okay, that didn't work. That's awkward.
9 just like ballooned.
Okay, wait, no. I don't want to multiply. Okay, so yeah, I want to multiply by 2 if the only odd integer, so if basically I want to multiply by 2 if it's even. So I want to multiply if n equal 1. No, I want to multiply if n not equal to 1. Else I just want to return this. So I want to return only, yeah, that works. Okay.
Oh, no way.
Yeah,
Shit,
so
this guy's crazy.
yeah, effectively what I was doing was really stupid. I don't know why I was squaring it. That was just really stupid. Because it only doubles my number of permutations, and I only want to do that if it's an odd number, or if it has odd factors. Effectively, I want to double it. But if it only has even factors, then I don't want to do that.
Wait, explain me this. Yo, Alpha, what's up?
Yeah. So
Explain me the
effectively,
solution. I don't get it.
I want to double my result at the end if n is not equal to 1. And if n is not equal to 1, up here in this while loop, what we're doing is we're dividing by 2 until we have a factor that's not divisible, until we have a non-even number. So if n
Why do we have
equals
to do that?
1,
Like, why do we have to divide by until we have an odd number?
I mean, we don't necessarily have to, but the way that it works, we're dividing by 2 here to effectively just get rid of all the even factors. So we only want to consider the odd factors in our
Why?
permutations, because the even factors can be just they're just going to double the sums by the way that they are. They're just going to double the sums because the consecutive numbers, if they're even, we can only choose one of the top two. So we can either say we have the option of 5, 6, 7, 8, or we have the option of 4, 5, 6, 7. I guess that doesn't work. But I guess my point is that, say we have these options, right? If it has an even factor, the sum is your number of possible sum sequences is doubling for every even, just for the even factors, for the odd factors. So if n modulo, if n equals 1, that means that the entire number is just effectively, it keeps dividing into, it's like, it's a power of 2, right? So we don't want to double if it's a power of 2. Basically, what we're doing here is we're getting rid of all the powers of 2 in our prime factorization, and then we're only checking the odds for the possible permutations of that.
Yeah.
I think this is probably
that makes
optimal,
sense.
But
Yeah, I think so.
I don't think I explained it.
I didn't even look at the question before I asked. I was just like, I looked up math ones and I saw this was being asked by Citadel.
I don't think I know how to explain math, because like the way I think about it is just really weird. Like in this thing, it just seems like obvious to me why we're doing this, why we're getting all the factors of 2 out, because it's effectively just checking if we are able to divide any odd factors into it. So we only want to, like, for this result, when we're multiplying to the result, we only want to, like, only consider odd factors in this, because if, like, say if a number is 32, right, the only possible sequence is going to be
wait, are you using the interviewer coder? I thought I saw something flash.
No,
I'm just kidding.
That'd be crazy though. That'd be a litmus test right there. See if you could figure it out. I think it would have notes on it though, right? That'd actually be helpful, because I could like explain it better.
What are you saying?
That'd be helpful. I could like explain what I'm doing better.
Yeah.
But like, so we have the 32, right? The only like consecutive numbers that are gonna work here would be 7, 8, 9. Actually, that's not true. It'd be like 2, 3, 4, 5, 6, 7. This work. 13, 18. 7, 9, 27. So we want to add 5. So I'm gonna get rid of that. I'm gonna do that.
It makes sense, yeah. I get it. Perfect.
Does it make sense?
No, I'm just kidding. I do not know what this question is asking. My math skills are terrible. But you got the answer. It's success. It was successful. I need to reread it.
Yeah, I don't know if this is technically optimal or not. This might not be optimal. I mean, it got 99%, so it like runs fast. I don't know if it's technically optimal, like for what you should do or not. Though.
Have I done this question before? Does that even count? Oh yeah, I've done this before, way back. But I remember I just read the answer. I just memorized the answer because they're asking the F bank companies. I was like, no way. It's crazy.
Well,
good job, Paul. I think you might have been the first one to pass the code question so far. I mean, Fahim got it, but with the O of n squared.
Yeah, I think I'm the only one. I mean, there's definitely like runtime optimal code. I just don't know if it makes sense or not. I need to like think about how to explain this.
All right. Thanks, Paul. We're gonna get. Wait, who's next? Let me see who's next. Okay. Paul, thank you. Appreciate it. Catch you on the next one. Peace.
Later.
Shehbaj, what's up? Strong no hire for making me look dumb. I hate when the candidates are smarter than me. Oh, it's tax day. Everyone, make sure you did your taxes. Everyone do their taxes. I did my tax. Guess when I did my taxes? Oh, Shehbaj. I did my taxes yesterday. Yo, Shabaj, what's up?
Yo, what's up?
Yo. Okay, wait. Let me get you onto the screen. Get you onto the screen.
Where's the which you want me to use the link that you sent, a coder pad that you sent earlier?
No, I'm gonna send you. I'm gonna get you onto a question. Give me a sec. Let me get you on the screen. How you been?
I'm chilling. Wait, I'm so confused.
Bro, that's actually crazy. You're the one who helped me with House Robbers 2 that one time.
Oh,
That's
dude,
so
that
funny.
was like that. I think you had like less than 1,000 subscribers, and I just like saw your live stream, and it was just so funny.
What?
And like you were going, I think you were live for like 24 hours.
Yeah.
And I was like, it was just hilarious. And like, you were so exhausted and you were just trying to solve House Robbers 2, and I had to solve it. I was like, dude, I can help you out. And then, like, I think like we like hopped on Excalibur.
Yeah.
It was just like funny. I was like trying to give you hints, and it's just you were just like so gone. It was very funny. I remember like I found that video, and like in the thumbnail, if you like zoom into the thumbnail, you'll see like House Robbers 2, and like you're like, thanks, Shabaj.
Yeah. I remember it now. That was crazy.
Yeah.
Yo, chat, how's the audio?
Wait, how did you like add the green screen? Well, that is wild.
Oh, that's crazy, huh? Yo, chat, how's the audio? Is Shabaj like? Okay, he's not like echoing.
Oh, because all right, yeah.
Yo, Shabaj, I ran into my first sub, and it wasn't you in the marina. So, some guy named Evan caught me on the streets, pulled up on me.
Why do you say marina? It's called a marina. Like
Marina? My bad.
It tells me that you've not explored SF. Like, how come you lived here for 4 years?
Nah, I didn't even know. Everyone just says random, calls it random. How you lived here all your life?
No, I moved here in 2024. I graduated college in 2023.
Nice.
So no, actually, I just moved to the marina. It was just pretty, and the sunsets here are beautiful.
All right, let's save you as much time as possible for this question.
All right, where are you gonna send me? Which coder pad do you want
Give
me
me
to
a
join?
sec.
The one in the Discord that you sent
I'm gonna
earlier?
send it. Give me a sec.
Where are you?
Okay, we got one. Only Paul passed his question so far.
Oh my
So.
god.
All the OGs are disappointing today.
All the OGs are because you're asking them hard questions. Wait, I just opened this on. You want me to open this on LeetCode? Like I'm
Yeah.
very confused.
Yeah, open up on LeetCode.
I have it opened up on LeetCode. And then what do you want? You want me to read the description from there?
Oh no, I sent you an invite. Or I sent you. Oh sorry.
Send me the
One sec.
wrong.
Okay, hop in the chat. Hop in now.
Okay. I need to sign into LeetCode. Okay. Yummy Shooter is here.
Let's get it.
Hello, hot. All right.
I gotta blow the air horn for Paul actually for getting it right. Alright, Shabazz,
Okay.
let's get it. How are you solving this one?
You're given an integer array heights representing the heights of buildings, some bricks, and some ladders. You start your journey from 0 and move to the next building by possibly using bricks or ladders. While moving from building I to building I plus 1, if the current building's height is greater than or equal to the next building's height, you do not need ladder or bricks. If the current building's height is less than the next building's height, you can either use one ladder or the bricks that cover the difference between the heights. Return the furthest building index you can reach if you use the given ladders and bricks optimally. Okay.
Optimally,
I think
yes, sir.
off the surface, it looks like It looks like a very like greedy algorithm problem. I'm not sure. Either it could be that, or it could be like somewhere where we might like use dynamic programming. Okay, so we have the heights, and do we have the explanation here? Oh no. Okay, let's just first read this so I can understand. Okay. So you started at building 0, which was of height 4. Go to building 1 without using ladders since 4 is greater than 2. Go to building 2 using 5 bricks. You must either use bricks or ladders because 2 is less than 7. Go to building 3 without using ladders nor bricks since 7 is greater than 6. Go to building 4 using your only ladder. Wait, how many ladders did we have? So we've only you must either use bricks or ladders. Using
Yes, sir.
ladders. Okay. Here, we didn't need to use anything because 7 is greater than 6. Go to building 4 using your only ladder. You must use bricks or ladders because 6 is less than 9. It is impossible to go beyond 4 because you do not have any more bricks or ladders. Okay. I think let's try solving this example here, and figure out how we got to 3. And what are we outputting? Return the furthest building index you can reach. Okay. So if we start at 14, we can get to 3 because 3 is smaller than 14. Now we're at 3. We need to get to 19. And right now we have bricks. Our bricks are 17. So to get to 19, we would need to use 16 bricks. So we get to 19, use 16 bricks, and now our bricks, we only have 1 brick. And now we're at 19, we can go to 3. And that's the end. So we were able to get to output 3. Okay. Let's look at this example. And the output here is 7. So we currently have 10 bricks and we have 2 ladders. We started at 4. We can either use a ladder or a brick. So we can either use a ladder or a brick. So let's just say in this case we use 8 bricks. So to get to 4, we use 8 bricks. To get from 4 to 12, we use 8 bricks. So we're only left with 2 bricks. Now we're at 12, we can go to 2. Now we're at 2. To get to 7, we must either use a ladder or a brick. We don't have enough bricks, so we'll use 1 ladder. That means now we're left with 1 ladder. And now we're at 7. From 7, we can go to 3. From 3, we cannot go to 18. Because, oh wait, we can go to 18 because we have 1 ladder. And now we're out of ladders. From 18, we can go to 20 because we have 2 bricks. Now we're at, everything is 0. From 20, we can go to 3, and from 3, we cannot go to 19. So, and let's count if we got to 0, 1, 2, 3, 4, 5, 6, 7. Well, okay. That doesn't help. I thought I would not be able to, like, I would get this wrong and then I would go back and try to find a pattern. I think is there okay, let's just say, let's just go back. Let's redo this example. Let's just say when I went from 4 to 12, I used 1 ladder. And so I'll try and do this example incorrectly on purpose. I used 1 ladder, so I'm only left with 1 ladder now. Now I can go from 12 to 2. I can go from 2 to 7. And let's just say I used 5 bricks. I used 5 bricks, now I'm left with 5 bricks only. From 7, I can go to 3. From 3, I would need to use the ladder because I do not have enough bricks. I do not have enough bricks. And so the ladder would be 0. From 18 to go to 20, I would need to use 2 bricks. So now I'm only left with 3 bricks. And from 20, I can go to 3. And from 3, I cannot go to 19. So here, again, I'm just stuck. So used 1. So we got 2. Let me double check if this was correct. From 4 to 12, yeah, I used a ladder. From 12, I can go to 2. From 2 to 7, I used 5 bricks. That left me with 5 bricks. From 7, I can go to 3. From 3 to 18, I need to use a ladder because I don't have enough bricks. And from 18, I can go to 20 by using 2 bricks. That would leave me with 3 bricks. From 20, I can go to 3. From 3, I cannot go to 19. So still the output is 7. Okay, I'm wondering if, like, just looking at this array, if I can just do, wait, is it is impossible, I'm wondering if I could, like, the naive way I'm thinking is, just like explore all possible like paths. So let's just say I was 4, I need to go to 12. Let me explore a path where I took the 1 ladder, and then let me also explore the path where I took 8 bricks. So I can like do this using recursion.
Okay.
Because I'm trying to find a pattern and I'm not able to find one just by manually solving it by hand. So I'm like, okay, let's just what's the naive way to at least do this? And then similarly, once I'm here, so let's just say the path that I took, so from here we can, so we can go to 2. So from now we need to go from 2 to 7. So let's just say I took to get to 7, I used another ladder, and
Okay, let's think about this conceptually. When will we use ladders and when will we use the bricks? Pretend.
we will use ladders. We will use ladders when we do not have enough bricks.
We'll use ladders when we don't have enough bricks.
When we don't have enough bricks, because that will force our hand. Like that will when we will be. Okay, so let's just see. When will we use ladders? When we don't have enough bricks to make the jump.
We don't have enough. So we're going to use up all our bricks first, then use our ladders?
Probably that's one way. That's probably like a greedy way, but it could be that that can be like one way of. It's just like you use all your bricks, and then at the end, if you're just left with ladders, go use them. But I think there could be like weird edge cases where like you should have like used a ladder in between, and then maybe use bricks at the end. But I'm not able to just like figure out like how to like what the algorithm of that would look like. I'm thinking like if there's a way for me to like do this like brute force way, like just the naive way of like just like figure like just doing taking every single route, every single the possible traverse every branch of this tree, and then maybe see if it's possible to find some
Yeah. I'll
like
give you I'll
dynamic.
give you I'll give you a small hint like okay, we should probably use like ladders, right? They essentially allow us to climb any amount of height.
Yeah,
So we should probably use the ladders on the biggest differences.
on the biggest differences. Oh, okay, okay, okay. Oh, I understand now. I think that, yeah, okay. Okay, so let's look at this. So I think what we can then
So pretend
do.
here, let's do this. We have 1, 10, and 1. If we have
Yeah.
brick equals 1, ladder equals 1. Like if we use the brick first, we're going to say that we can't even pass it. We can't even
We
get
can
there.
even pass it. Yeah, 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 yeah. So I think for this 1, 10, 1 example, uh, here this is a starting, but to get here, the difference is 9. And here we can get to this spot. And so to make this jump from this to this, we can use the ladder because it's like
Or shall I
the
use 11? Actually, let's change this to 11.
okay, okay, okay. Let's change this to 11. In that case, the difference is 9. Here, the difference is just 1. And we can just okay. Okay, we can keep track of, so the difference between 1 and 10 is 9. So to get here, we need 9. The difference is 9. To get from 10 to 11, the difference is 1. Okay, let's look at this one. Here we are at 0. To get the difference here is 8. The difference here is just 0, because let's just assume 0 because we can get there. The difference here should be 5. We can get to this part. I can hear the air horns. The difference here, okay. The difference here from 18 to 20 is 2. And the difference here is 0, and here it's 16. So let me double check. Okay, we need 8. From 2 to 7 we need 5. From 7 to 3 we need nothing. 15. And then we need 20. And then
50k subs, let's go!
from
Focus
20
up,
to
focus
3 we
up.
need 0. From 3 to 19 we need 16. Okay, I see now. And I think what we can then do is, I'm wondering, now that we have this difference array, I'm wondering if we can store these elements in what's it called, a max heap. I'm wondering, what if you could just maintain a max heap of these differences, and whenever you oh no, that would not work. That would not work. That would not work. That would not work.
Gotta hit the. Oh,
Now,
he lagged.
okay,
He
now
lagged. Gotta hit
Oh,
the
I
horn
lagged?
for the 50k. I hit the 50k.
Oh. So you hit 50k while I'm struggling with this question. Okay. Okay, so we now have the differences. Okay. I think all I now need to figure out is how to okay, so now that I know the differences, all I need to now figure out is how to do the lookup. What if I'm going from 4 to 12, and how do I know that it is one of the largest differences? Oh I think, oh yes, okay. So okay, I understand now. Wait, for this question, how many ladders did we have? We had for this example, we had we only had 1 ladder. Or how many? Oh no, we had 2 ladders. Okay, this helps. So we have 2 ladders, and so all we need to do is find the biggest, like the top, the max L. So it's like you like sort the list and like find the top, like the biggest two numbers from here, which should be which should in this case should be 16, which should be 16 to 15.
Yeah.
But that would be incorrect because we know that once we did this by hand, we cannot get to 19. But we would. Oh, but I think when I did this by hand, okay. Let's just assume. Okay, and I think maybe once we start, then once we start to, so we can probably just like put them in a set then. Maybe like sort this differences list and put it in a set. And once we know that we're at a difference where like it's in this set that we saw, we can just use a ladder, like decrement it, and then move and keep moving. So like here, the difference. So let's just, so we know that the biggest differences were 16 and 15. So let's just say from 4 to 12, we know that the difference is 8. So we'll use the bricks. And how many bricks did we have? We had 2 ladders and we had 10 bricks. So we used 8 bricks, and now we're left with 10. So now we're left with 2 bricks. From 12 we can go to 2. From 2 we can go to 7. We know that the difference here is 5. It's not in the biggest differences that we saw, so maybe as a, like the only other, like our hand is forced here, so we will need to take the 1 ladder. So, and from 7, from 7 we can go to 3. From 3 we need to go to 18, and the difference here is 15. It is one of the largest differences that we saw, so we'll just use 1 ladder, and we can then set ladder to 0. From 18 to get to 20, we will just use the bricks because the difference is not the largest that we saw, 2 bricks, and now we're out of everything. And from 20 we can go to 3, and from 3 we got blocked. So this is what I'm thinking, but I feel like it is like working here, but it's like I'm trying to like think of an example where this would break.
So what are you doing? You're storing the differences?
Yeah. Like here are the differences, and then I'm only storing the top. Like if you take L as a number of ladders, I'm only storing the top L differences. But it could be that, like, you know, let's just say if this was, you know, 0, 100, because we know we can have progress from 19, and like let's just say this was 200. Like my biggest differences would just be like 200 and 100. Like it would just be 200 and 100, from going from 0 to 100 and from going from 100 to 300. And in this case, I'll just like use just the bricks. I'll just keep using the bricks, and at the end, like I think when I did this example by hand, I just ended up using the bricks, and I think it just like worked fine. But this is the only edge case where I think like things might break.
Okay, what's your exact solution? Sorry, I was looking at the chat.
So what I'm thinking is just like store the top L differences. So if L here is the number of ladders, store the top 2 differences, and until we do not see one of those differences, just keep using the bricks.
Okay, but like the top L, like what if we can't even reach those? So we should have used the ladder before.
Yeah. We should have used the ladder. That is correct.
Like we're holding off to use ladders to places we might never ever get to, right?
Yeah, we never ever get to.
Is there a way to try ladders? Like, is there a way to keep a running count of the top two and maybe try those? And if something comes in bigger, use
Wait, if something comes, oh, the running count.
or like storing like the top ones that we've seen so far.
The top ones. Oh, so you want to do it running wise, and the top. Oh, okay, I see. So okay. Oh, okay, I understand now. I think maybe we could try with like a heap then. Okay, 100, and then this is the difference here is 200. Okay, so if we want to go, okay, so let's just say we like maintain some like max heap. Okay. Then from going from 4 to 12, the difference here is, so our heap has nothing. So our difference here is 8. And this is the max that we've seen. So we can probably just use one ladder here. And then we can just pop it from the stack because we have seen this difference. And then from going from 12 to 2, we do not need anything. And then but then if we go from 2 to 7, the difference here is 5. But if our max heap is empty, the 5 is still the max element that we have. It is still the max element that we have. So like by that logic, I'll still use the ladder here. This would probably not work if I just end up using all the ladders because then I'll pop this off. No, let's see. I can probably code the naive solution, but let's think. If I want to keep a running count of all the max differences I've seen, I will have to store them in some sort of a heap where I can just like look at what's the max.
2 minutes. 2 minutes.
I guess we'll just take the L, man.
It's close. It's close.
It's something with a heap.
Nice try, man.
It's cool. I'll probably this is a nice one at least. At least I was able to like think the naive way. It was great. Did I hit 50K? Did we hit 50K during
Yes,
this?
sir. We hit 50K. You're locked in. That's why he's blowing the air horn the whole time.
So we hit 50K while I took this
Yes,
L.
sir.
That was crazy.
But thanks for helping me out with that house robbers that one stream.
So
I couldn't do that without you.
this is a good question. Shout out to Paul. I don't know how you figured that out.
You saw his last one, right? That was crazy.
And I was cooking food, so I didn't look at it. Yeah. Paul is crazy. Is Paul the Code Forces guy?
Nah, it's Paul. Paul's some other. He's just in the chat all the time.
Shout out Paul.
But he did math competitions though. That's why.
Dude. At least you didn't ask me a math question. I couldn't been able to make any progress.
Yeah.
All right.
That's why Paul does math competitions. I don't think he does Code Force. But Shehbaj, thank you for hopping in. Nice try again. We'll get you on again soon.
We'll get it next time.
Yeah, you gotta show me your vibe coding setup at a different stream.
Yeah. Okay. Well, my vibe coding setup. I'm just like updating it. I have like a widescreen monitor, and so it's not good to stream. So I have to like next time I'm just gonna like stream in like 1080p 1920.
Nice.
Otherwise, it's very hard. But it's cool. All right. Good luck to
Shehbaj.
whoever.
Alpha's next.
All right, oh fuck. Okay. Wow. So we had a cracked person. Then we had me. Then we're gonna have another cracked person. Damn.
Let's see. I'm asking him. I got him for a hard question, but
No,
I'll catch you,
All
Shehbaj.
right. Good luck to
Okay.
Alpha. Bye.
Peace. Yo, Alpha.
Hold on. Can you hear me now?
Yo, what's good? Damn, we're 1 for 5 right now. Wait, okay, I can't hear you. But everyone got close. Good job for Shehbaj, everybody who hopped in. Wait. I can't hear you. Wait.
Okay, can you hear me now?
Yeah, perfect. Yo, what's up?
Hey.
Okay, redeem the subs.
Dude, I might get cooked. I mean, it's like 8 p.m. I was working all day. Not a good. We'll see what happens. I just did the problem with the day thing. Did a video on that. So.
Oh, nice. You just dropped the video? Bro, you're a savage.
All right. Let's see.
Okay, I'm gonna send you an invite in the chat.
All right.
Yo, chat, how's the audio? Oh shit, wrong one. Sorry. Give you an easy question. No,
Easy? You think so?
Nah.
All right, let's see. That's the right one. Oh wait, no, I joined the wrong one. All right. Am I in here?
Did you get the last one? Did the last one make sense to you? The last question? Use a heat.
Mm-hmm. Yeah.
Damn, I used a binary search. That was weird, but the one y'all were saying was good. That one makes sense.
Mm-hmm. All right. So we have an unsorted array. Return the smallest positive integer that's not present. Okay.
Cooking already.
Okay. I think usually when I had these types of problems, I would just change the number to something to know that I was there before, and then you can like change it back. So I'm trying to think if that'll work.
What do you mean by that?
Yeah. So can you see me type?
Yeah.
So I would just say like, all right, so like 1, for example, should be at, let's see, are these all numbers are 1, 10 to the 5th? Yeah, okay. So I could just say like, all right, so 1, that means if there's a 1, I'm going to mark index 0 as visited. So I can't use another data structure, but I can just like change the number. So I'll just make it like 1 plus 10 to the 6th or something. And then 2, I'll do the same thing. I'll say this location is visited, so I'll do this. And then 0 we'll ignore because there is no 0. So anything like outside of the range we'll just ignore. And then what we can do is we can just loop through like, or we can just say like loop through, 1 to whatever until we find something. So we can say like, all right, for 1, that's going to be at index 0. So in order for this to have been visited, this number needs to be 10 to the 6 or bigger. So it is visited. And then 2 is going to be over here. So it's also visited. And then 3 is going to be over here, and it's too small, so it's not. And then if you want to change the input back, you can just take every number and like mod it by 10 to the 6th to revert to what it was. So you're essentially just like manipulating the input to mark things visited, and then you can just like do it that way. I think that makes sense. So that's what probably I'd go with. Does that make sense?
Wait, could you repeat that? So we're looking for the first positive integer, right?
Yeah. Okay. So actually, I read the constraints wrong. So these numbers are, so these numbers are.
Could be any number.
2 to the 31 to 2 to the 31. So I can just use some bigger number because it's Python. Like I can just add like 2 to the 35 or something, right? I'll have some constant number here. So basically what I'm going to do is every single number that's there, I'm going to mark that location as visited just by adding a number. So like 1, I'm just going to add this to it.
Sure.
2, I'm going to add this to it. And then I'm just going to loop through all the numbers like until I find something that's not there. So does that make sense? Like essentially when I see that number, I'll just mark that index as visited. And then I will to mark it as visited, I'll just add some big number to it. and then I can revert back if I need to. Like if you want the numbers to be.
Why are we marking it at okay? And then you loop from 1 to what?
2 until I don't find something. So like for 1, I'm gonna check index 0. So I'm gonna check like index 0, because 1's gonna be at index 0, and then 2 is gonna be at index 1, and so on. So like I'm gonna check index 0. Is that number greater than 2 to the?
Or the array isn't sorted, right? The array isn't sorted.
No, it's
unsorted?
not. But I can still mark things as visited just by adding like a big number. So I can just add a big number, and then that means that the number is visited essentially. And then if you want me to make the output back to what it was, I can just loop through it again, and just any number that's bigger than whatever I added, subtract that thing back to make it like the original input. So it's like I'm just gonna basically manipulate numbers in the input to mark them as visited, and then I can change it back at the end to keep it like.
Wait, I'm just confused. Like, why do we need to mark it as visited again?
Because so imagine like all these things, like this nums is length like 30 or something, right? So it'll be like
Sure.
index 0, index 1, index 2, index 3, index whatever, right?
Well, it won't be
For
sorted
every
though,
number,
because yours is sorted.
it won't be sorted. It'll still work if it's not sorted. Like let's say our numbers is like 32 or whatever, 312, right? Let's say it's this way. So what's gonna happen is for 312, index 0 is gonna be where the 1 is, index 1 is gonna be where the 2 is, and then index 2 is gonna be where the 3 is. So I'm gonna say like, all right, so we have a 3. So I'm gonna mark index 2 as visited just by adding some big number. So I'll just call this like big.
Okay.
And then for 1 is going to be at index 0, so I'll add here. And then 2 is going to be at index 1, so I'll add like big. And then I'm going to loop through 1 through whatever, like until I just find the number that's not there. And I'm going to check is the number there. So 1's at index 0, so I'm going to check is index 0 at least big.
I see.
Like,
I see.
It is, so I have it. And so whatever the first one I don't find will be the answer.
I see. I see.
Yeah. I basically just need some way to mark things as visited without using another data structure. This is one of them. You can probably use some other stuff, but yeah, I think this makes sense to me. And then this won't be like extra space because I'm just.
There's negative values too, right?
Yeah, it doesn't matter. I can just use some big value like 2 to the 40, and then it won't matter. Like -2, because this is Python. Like -2 to the 31 plus 2 to the 40 will still be bigger than whatever, like 2 to the 32. So I'll just check for that condition. If it's bigger than 2 to the 32, it's not going to matter if the number is negative because I'm going to be adding such a big number. They'll all just be huge.
Okay. Sure.
Okay. So let's go with that. So basically, I'm just going to make this big number like like 2 to the 40. And then the main trick here is whenever number is bigger than, I'll say check will be like 2 to the 32, let's say. And you can probably optimize this a little bit better, but this is just going to be the fastest to make it work. And then, yeah. So it can definitely, code can be cleaned up, but essentially, so we can go like 4 IV. Actually, I don't even think we need, we don't care about the index at all. So for num and nums. So we're going to say like, if num is greater than 2 to the 32, that means we added this big thing to it, so we'll go subtract. And this is like our original number. And then from there, we need to check, is the original number something we need to mark? So if the original number is negative, we don't need to mark it. Or if it's bigger than the length of the array, we don't need to mark it. So like if the array is 4 and the number is like 10, that's never going to be our answer. Like we only need to mark 1 through 4. So essentially we can say that. So if num is less than 0, or less than or equal to 0, or num is greater than length nums, we can just continue because we don't care. Okay, so now we have to actually mark this index. And so the index will be num minus 1. And then this could have already been marked. So we can check for that as well. So we can say like if nums I minus 1, or actually why did I say, oh yeah, on nums I is greater than, I guess we can use this, check. That means it's already marked, so we can just continue. Else we will add the big. Okay. So now, let me just print the nums just to make sure we kind of did the right thing.
Runtime error.
We got an error. Yeah. Oh, this is just this. All right. So in this first example, you could see we marked index 0 just by giving it some huge number, and we marked index 2. So index 0, I think this is not correct. Because we should have marked index 1 and index 2. Because we have a 1 and a 2, we don't have a 3. So we did something wrong here. And yeah, so let's think about, I guess, what we did wrong. So you can also just print it at the end of every iteration just to see like what's going on. Okay, so at the end of the first iteration, we marked index 3, which doesn't make any sense. So that's already wrong. So if num is greater than check, it's not. Or, oh, we need to add. Let's see if it works now. Still no. Okay, so if num is greater than check, or sorry, this needs to be smaller. Yeah, smaller than check. Okay, there we go. Let's see if it's good now. We got a null. That's weird.
Well, you're not returning anything, right?
Yeah, because we can have continues. Let's just print at the end. Okay, so here it didn't do anything. Interesting. So if num is less than check, num equals big, continue. Do we need to do anything else? Let's think about it. Actually no, this was screwed up. This was correct. This was correct. So this is fine. So this was, yeah, let me just write down a comment. So this was number is already big, so we're getting the original. Okay. So we're getting the original. So this is fine. So if num is less than 0, or if num is greater than length nums, continue. So that won't be the case. Num's I is greater than check. Okay, let's try this again. Index at a range. Or I is so if length num is 3, the index should be 2. Yeah. So actually, I think this was correct. Yeah, so this is fine. Okay, so yeah, essentially I here should be 0, which is correct. If nums I is greater than check continue, it's not. Nums we already did this, so this is just I. Okay, now let's try it again. Okay, now we have the right thing. And let's just check if we have it for the rest of them. So for 3 and 4 and 1, yeah, we could see like the right indices are marked as visited essentially. And yeah, okay, this is good. So now all we have to do is just loop from 1 to whatever. So we can just say like res equals 1 while res is less than or equal to length nums. Nums res minus 1 is less than check, I think. Then we can just do this. And then if it's not, we just return results. And then I think we should be good. Okay, apparently not. So let's see. So let's print some more. Yeah, I feel like this is just like not a hard question. I'm just like screwing up in really dumb spots, but let's see. Okay, so we have nums here. Okay, so res is less than, that's true. It's the other way. Yes, other way. That means it's here. Okay, now let's try it again. Okay. Now let's. Okay, there we go.
Damn, this guy's crazy.
Yeah, so you can revert the numbers back pretty easily. You can just like basically loop through it again. So you could say like for IV in enumerate nums. If
Paul's saying you're using log n space.
yeah, but it's like really small. I mean, I guess it's like technically log n, but it'll be like the space will be like 5. Like it's still kind of constant. And for these types of problems, like generally, if you have a big number, it's still referred to as constant, I guess. Because yeah, basically it'll be like log whatever. The space will be like 5 or something. It won't be very big. I guess I could think of how to do it without doing any of that. So maybe we could think of like the other solution.
Oh, I see. Okay, let me look at. Okay, I see what you're looping through for the length of nums, and then you're just checking if it's greater than check. I see.
Yeah, I mean, I can add something.
No,
I
this
can
makes
add
sense.
something
Your solution
smaller,
makes a lot
like,
of sense.
I can add something smaller because, like here, the number is 2 to the 31. I can add like 2 to the 32 or something. So basically, I turn every number from like an int to a long. So I don't need to add something as big as 2 to the 40. I can add 2 to the like 33 or something would probably be even fine. Yeah.
No, that's fine. It's
and
it's
so
snip.
that basically fits in a long. So
All right, let's move on to the next question. Let's do it.
Okay, next question.
This guy got enough time for a second question.
Next question. All right.
Yo, Paul, he's about to pass you if he gets 2 questions. Let me find a good one.
Yeah, I have the chat muted, so
Yeah.
hard to say. Alright, time to find that rectangle one.
Oh heck no.
Dude, we only have like 15 minutes, right? So
Yeah, I'm trying to find a
has to
good
be
one.
solvable. Like, how about you have to be able to do it in like 30 minutes, and then you're like
30 minutes?
Yeah, if you can do it in 30, then you can ask me for 15.
Let's see.
If you're dazed and confused, then we gotta ban it.
Yeah. Let me find one. No, I'm gonna find. I won't find the crazy one. Let me see.
Okay. For that rectangle, I actually have it solved, so I could just paste the solution and be like, oh yeah, I remember now. It was that. I mean, I'm gonna get stumped eventually. Like, I don't solve all these, so it'll happen. Maybe for that Paul one, I also might like the math ones are pretty hard because I don't know the math super well, and Paul just comes up with some crazy like optimizations.
No, that was crazy. Let's see. That's your random one.
All right. Just hit me with like a sequel, and then I'll be cooked.
Okay, I'm gonna end this one.
All right. Let me see if I have it solved. If I do, I'll delete it. I don't remember, so. Okay, it looks like I don't. Okay.
Yeah, we might not be able to get to coding, but if you could come up with the solution. Oh shoot, wrong one,
Yeah.
wrong one.
Give it my best.
Okay, hop into this one. Wait, is that the one? Yeah.
Okay, I gotcha. Number of ways to reach a position after. Okay. Start. Alright, so we can just do this to start. Didn't even read it, but gonna need that. So. Alright, so you're start, infinite. You can move one left, right, K. Number of ways, reach the end, starting at the start. Perform exactly K, okay. The ways are considered different if the order of steps is not exactly the same. Okay. So, I mean, one thing I'm thinking of is DP, but like right away. But let's see if this will even fit in the constraints. So we need to be there at K. Alright, so start ends 1,000. What's K? 1,000? I see. Yeah, I feel like DP, like we can basically go left or right, so we can just keep track of let's see, index, and then like however many steps we have left, and then we just have to check like if when we have no steps left, we're at the index, we return 1, if not 0. Is that right? Or we need to be at the end position. Yeah, we need to be at the end position. I mean, there's some like optimizations we can also do. Like we can.
Yo, Shehbaj, thanks for the donation.
And the end position, and if we don't have enough steps, we can return 0 right away. That would be another one. Yeah, I'm pretty confident it's just DP. So you want me to just code up a DP?
Yeah, code up a DP real quick.
Real quick. All right. So for DP, since it's Python, we got a cache built in, so easy. All right, we got steps left. Alright, so we can say like, oh, whoops, FP. Alright, so we can say if absolute value of I minus end is greater than steps left, then we can just return, it's already impossible. Then we can say if I equals 0, or steps left equals 0. And then, so here we could just say like if I equals end position, return 1. Return 0. And then we just have a choice of like left and right. So we can just say like return dp. So, we got to make sure we don't go to the negative. So I guess we can just account for that. So yeah, it's another thing. So we could say like if we can account for both of those. So we're standing, oh, it's an infinite number line. Oh, so can we go to a negative actually, or no? I didn't look in the thing. Yeah, like can we go to a negative number? Is that allowed? I have no idea.
It includes negative numbers.
Okay, so we can go. Okay, cool. Okay. So
Note that the number line includes negative.
Oh,
Yeah,
okay, yeah.
the
Okay.
verb
So we don't have to worry about that. Okay, okay. So we can just do return dp I minus 1 steps left, or this is 0. So I guess not steps left. All right. Yeah. So this is this, and the other case is just the other one. All right. Let's hope for the best.
This guy's cracked.
So we started at start position, and steps left is k, I think. We need to mod it by mod as well, so we can do mod here, mod here. Did it work?
I don't know. Damn, Matt, that's the third one.
Dude, I can screenshot
Hey,
this
good guy
one.
got 7 left.
I've never
Yeah,
done this
third one.
Pretty, third one. We got 7 minutes.
This guy's going crack.
That's what I'm saying. The DP stuff is like once you get it, it's super fast. Like it's literally, it's like I can only go left, I can only go right. I have a base case, I'm done.
Okay, I'll match you an easy one. So you can get the third.
All right. Yeah, just give me the two-sum. Two-sum recursive.
Alright, got one more. This guy's going crazy.
All right.
Yo,
See if I
Paul's
did
showing out right now. He's making it up for the last people too. Cause what is it? Second one? Okay, wait. Let me see.
Yeah, I gotta see if I have it solved and delete it. So just send it and then I'll.
Paul's like, my son is
Or
making
actually,
me proud.
if I join yours, I don't see my solution anywhere, right? So I can just
Yeah.
if I do have it solved. Okay. Yeah. Yeah, I mean, I did a lot of problems, so I solved most of them, but I solved most of them like 2 years ago. This one I haven't done, which is kind of surprising. The other one I
Hop
did
into this
do,
one.
but, like a long time ago. All right. Did you link it
Yeah, I sent it in the chat.
in the stream chat?
Or in the Zoom or the Meets.
Oh, okay, I gotcha. Type of triangle. Okay. I gotta leave the other one.
Yeah,
See if I
leave the
solved
other
this before. Oh, okay. I do have a solution, so I'm gonna delete it. Or we could do another one. I didn't see what it was, but either one.
one. Just run it. Whatever.
Okay.
Are you in it here already?
Yeah. Okay, so given 0 index, I mean it's an easy should be like 2 minutes hopefully. So 0 index integer size 3 form size of triangle equilateral isosceles. Okay. Type triangle can be transformed.
But you're not in
Yeah.
my you're not in my.
Oh, let me rejoin. Maybe that's why it showed my code this week. Okay. Am I in it now?
Yeah.
Okay, so equilateral, they all have to be the same. And then I believe isosceles, 2 of them have to be the same, but I think there's some rules. Okay, so I know for sure that so I could do this. So like if nums 0, or I can just do literally if min nums equals max nums, return true. So that's equilateral. If they're all different, I think the first 2 have to be bigger than the third.
First 2 have to
And
be
if
bigger
2 are
than
the
third.
same, I don't remember what if the third side. I think the third side has to be something. I think the third side can be anything. So I think if two of them are the same, then it's also true. So I can just say like if set nums like this is 2, and then I guess we'll see if it gives us an edge case. And I think if they're all different, the first 2 have to be bigger than the third. I think. So
why are you returning booleans and stuff? I think it says.
Oh, what do we return?
Or
the
go
type.
yeah go yeah.
Ah, okay. So this is equilateral. This is isosceles. And the third one is, so if nums 1 or nums 0 plus nums 1, I think the first 2 have to be bigger than the third, I want to say. I don't remember for sure. Return scalene. And otherwise return none. I mean, this is just going to show me an edge case and then I can fix it, so it's kind of like cheating, but let's see. Okay, so 844 was isosceles and it was none. Okay, I see. So there's a requirement for isosceles, and I don't remember what it is. Oh, fuck. I feel like the third side has to be. Can the third side be bigger? Yeah. Oh, I think it has to be. Let's see. Like, if you just use like Pythagorean theorem, like how big can it be? I don't remember. I mean, I guess we can just do. Oh, actually, no. It doesn't work with Pythagorean theorem.
Wait, what did it return no on? Let's look.
844. So you can't have 844. So the third side has like a condition, and I don't remember the math rule for like what it has to be off the top of my head.
I think
Like,
there needs to be a check. Like.
No, I know. I just don't remember what the check is for
Triangle inequality or something. They're saying. 844 can't be valid. They're saying.
No, I know it can't. I'm just saying I don't remember how to check for what the third side, like what the range of the third side has to be. Off the top of my head.
Chat, help out with like. Let me
I
think.
need some chat assistance for triangle stuff. It's
Paul's like
literally
lead coder doesn't know triangle.
Yeah, I don't know triangle, dude. I see. Oh, it's invalid. I see. That makes sense. Yeah. Okay, so yeah, so this is if num 0, that makes sense. So I had it right. I just had it in the right order. So if this is less than nums 2, or maybe equal, I guess we'll see. Return none. I need it this way. Okay. Yeah, let's see what happens here. Yeah, it's too hard, man. 538 null expected. Oh, did I do null? I guess it has to be this way. Okay, there we go. Okay, I got cooked.
Woo! 3. Got cooked on the easy. No, you still solved it.
Like on the scalene, I knew that like, the first 2 have to be bigger than the third, but I couldn't figure out for the isosceles. It's too hard. That's why the math would cook.
That's so funny. Yeah, I did not. I haven't done triangles since forever.
Yeah, I knew for sure that like the first 2 had to be bigger than the third, but then that should obviously be the same for isosceles. So yeah, I cooked myself.
Yeah, Paul, I remember this question. I remember there's some condition, but I forget. So the condition is just. Oh, nice. Farzan's in here.
Yeah, the first 2 sides have to be bigger than the third. All right, I'm gonna hop out, I guess. So best of luck to the next person.
Yo, Farzan, what's up?
Yo, what's up, man?
How you been?
Congratulations. Been doing
Appreciate
good,
it,
doing
man.
good. Just tired. Just got off of work.
You just finished working right now?
Nah, but like I just got back home, but I did work like pretty late, and I like went to the gym, but you know it's all good.
Damn, you're grinding, huh? Trying to get that promo fast as you can?
Yeah. That's the goal. That's the goal.
How long do you think it usually takes there at your current company?
I mean they're like pretty chill. Like they're not gonna like fire you if you don't get promoted fast, but I'm trying to get it in like less than 1.5 years, which I think it's pretty fast for the company.
Yeah, I see. Cool. How many leak code questions you solve again? I feel like we haven't really done a leak code question. We just talked about like career and stuff.
We haven't yet. No, I've done like 800 something, but I'm like
800?
Yeah,
God
but I'm gonna
damn.
be pretty washed for this. Like, okay, not gonna lie, the first couple hundred were like, I don't consider them as really valid, but it's all good, no excuses.
Farzan, you're the one that what's it called? You go to Salesforce, right? Work at Salesforce or no?
Yes, yeah, that's me.
Yeah, your voice sounds different today. I feel like we did the 2 videos, right? You're the one who hopped on and you're like, what's it called?
Yeah, because
Help me
maybe
get
I'm
a
not
job.
saying. Yeah, maybe I'm not saying like as much, dude. Maybe that's
You
it.
fixed it up, huh? That's
Yeah, I saw
crazy.
a lot of comments. I'm like, I need to work on that. I just said it, but
Yeah.
is what it is. Oh wait, did you
All
post
right.
the link in the?
No, I'm about to post it. 800 questions is crazy. What's the breakdown?
Like 520 medium, like 190
Oh
hard,
my
and like
god. You're
160
crazy,
or
bro.
160 hard and like 190 easy.
Okay, you're gonna body this question.
No, I don't think so, man. It's gonna be super embarrassing, but it's all good. All right, let's see.
800 is crazy.
All right.
Luis got trolled by 3 different. What do you mean trolled by 3 different Salesforce teams? But go ahead, Farzan.
We trolled by 3 different Salesforce teams. What? Okay. Yeah, let me go ahead and read this question. Okay, you're given an array of routes representing bus routes where routes I is a bus route that the ith bus repeats forever. For example, if routes it travels in that sequence forever, you will start at this bus stop source and you want to go to the bus stop target. You can travel between bus stops by buses only. Return, so it's the least number of buses you must take to travel from source to target. And then it's let's see, return -1 if it is not possible. I see. Interesting. Okay, so I guess like the first thing that I'm like thinking of is it's a shortest path. Is kind of graph-ish. It is a graph problem and a shortest path. The constraints seem kind of like routes length 500. Okay, I think this might be like I think we can try to form this into like a graph problem and potentially use like BFS if that makes sense. All right, let me look at the problem one more time. So 0 bus travels. Okay, got it. Let's see. Yeah, let me just think about how like I would like solve this. So we first like I'm just gonna like lay out the steps and do, like multi-line comment. So step number 1 is like create the graph, and then like once we have the graph like ready, we can probably like again start off like do a BFS where we have like a deck. We start off with our current location, like the number of moves, like once we get there, if we get there, we can like return kind of the total number of stops that like we took, if that makes sense. Okay, so I guess the first thing is like what's the best way for us to like enumerate this graph, or for us to like lay this graph out. So source, okay, so you're not on any bus initially, and then routes is so we can start from any bus then if let's see. Oh no, you'll start at bus stop source. And
Alex, thanks for the donation. Appreciate
so we
you.
essentially want, and then from 7.
Caesar 2 from back.
Looking through the example here, is to take the first bus to bus stop 7, and then the second bus to bus stop 6. Okay, I see. So, let me think. I see. Okay. Oh yeah, this is like kind of trippy because like the actual stops are kind of like the indices themselves. So or the 0th bus goes like 157, 157, 157. Okay. What we can maybe do here is we can create like a graph, such that we have the graph and each bus or we can have sort of like a let's see, we need some sort of mapping between the actual so I'm just gonna say like need some mapping between the stop and like the bus. So for example, we can have like let's see, the actual stop and the bus. So we have, for instance, wait, this is kind of complicated. So we have source and we have target. Let's see. So 0 bus goes 157 forever. Wait, let me think about this. Okay. Wait. When in doubt, right? Let's like solve the trivial case, right? So if source equals target,
Yeah.
return 0, right? Let's get that out of the way. And then let me think. Other than that, we want to have a yeah, I'm honestly like kind of like thinking about how we can like create, like I'm thinking about how we can sort of create the graph for this. So let's see, if we have all of the routes, so let's say we do like for I in range like len routes. So these are all the routes, is a bus route that the ith bus. So, or we can just do like for bus in range len routes, we can say like the stops for bus will be like routes bus. I could just use like enumerate, but that's fine. And then let's see, we want essentially for every stop that this bus takes. So for every stop that this bus takes, we can basically have like a hash map that maps this stop to this bus, if that makes sense. And then we can use that hash map in like our BFS, where we essentially go from stop to stop. We can then use the hash map to see, hey, from this stop, like what buses can we get to, if that makes sense. Okay, does that kind of like make sense? Like
Yeah.
we want sort of like a hash map. We want like two mappings. One that essentially, and I could just maybe write it out here. It will just basically look at like for the stop in stops for bus. Like we can essentially do like hash map like stop dot append bus, or we can just do like I'll just call this like bus to stops equal to default decant, and yeah, we can do bus to stop dot append bus. So like again in this case, for each exact stop, we'll have like all the buses that kind of go, you know, like in this stop, and we can use that in like our BFS, if that makes sense. The other thing now that we want to do is let's see, we also essentially want, so we have the zeroth. So if we have over here like all the individual routes, and this is, so like route 0 means the 0th bus. Okay, goes 127, 127, like 127, indefinitely. Let's see, how can we like use this bus to stops to maybe, let's say, like create a hash map where it's just going to be, I guess, like stops. What we can maybe do is we can do like, if we had just a graph with stops, we can now like call this default. We can just, this can be another list, and this can be the actual graph. And I think what we can do here is we can also do something very similar, where if we do for like bus, and we do for bus, and like I guess stops for bus, and enumerate, I guess, what is it, route? What's a variable called? Routes. We can actually now formulate this graph. So if we again just iterate over all of the stops and stop per bus, we can do stops graph in this case, we can just do, let's see. Yeah, so for all the stops in this, we can do stops graph I. I guess we can just do dot. Let's see for all the stop. Stop graph, or it'll be stops graph like bus, and we can just. Well, we want to have like all the list of buses that like that map to each other, if that makes sense. Let me think. Wait, does it make sense what I'm trying to do here? Like,
Yeah. So you're trying to build out this adjacency list essentially. What does this look like? This is adjacency list you're trying to build out, right?
Yeah. This is like a mapping from like the bus to all the stops that it goes through, and then
Okay.
this is like
What would that look
essentially-
like here for this route here? Like for this, what would that look like when you say this is gonna be?
Yeah, it'd just be like wait, let me just write this down. It'd be like one. It'd be one, for instance, and then it would just be like 0. It'd be 2, 0, and like it'd actually be like a list. And it'd be like 7, like 0, and also like 1, right? And then it'd be 3, 1, and then it would be like 6, 1. Does that kind of make sense? Like 1,
So-
0, 2, 0.
1, 0.
It'd be 7 will have 0 and 1, right? Because this exact stop, like it's fulfilled by both buses 0 and 1. 3 is
Okay.
fulfilled by bus 1, and 6 is only fulfilled by bus 1.
Do we care about what bus though?
Let me think. No, not really, but like my idea is basically like we can imagine this as maybe like this like stops graph. Like we can just maybe consider this as like an adjacency list of like buses instead. So maybe instead of like stops graph, like I guess if we have a see, I'm saying like, man, I'm getting nervous, but I need to stop that. Okay, if we have a buses graph, right? My end goal is we can somehow convert this into an adjacency list where, you know, we can do a map from buses to other like different buses, if that makes sense. Let's see. So if we have a buses graph, essentially, let's think how we would solve this. So if we have a specific graph that is just for buses, and then if we iterate over for every stop in buses, let's see graph. Then what I'm thinking is we can essentially do like buses graph dot extend the stops for bus, or no, it'd be bus to stops. Stop. So previously, or it'd be for stops and stops to bus. Let's see, bus to stops. Okay, wait, I think I like labeled this wrong. This should be, instead of stops for bus, I think it should be, let me think. I don't know if I called this the correct name. Wait, okay, so for bus, and so for every bus, we have stops for buses, routes bus, and then bus to stops. Okay, no, so this is correct. So at the end of this, what we have is we have buses graph. It is going to like be a graph that maps all of the it's essentially just a graph that has like a single bus, and then it maps it to all of the neighboring buses that it can go through. So we kind of like we inverted this. What we were given to us was we were given for every single bus which stops does it go through. So far we've kind of inverted it. We found for every single stop what buses go through that stop, and from there we formed a graph, buses graph, which now just connects the individual buses, if that makes sense.
I see. Okay.
So the final thing here is we have a target stop, right? And what we can do here is, now that we have this buses graph, we can maybe just in a set, for instance, kind of just figure out, like, let's see, like we can essentially see whether or not, it's kind of interesting. Yeah, we would essentially want to see, well, we first want to have like a like arrival stops is what I was talking about. Is we want to have just a sort of arrival stops where for the target stop we want to see, well, which buses go through here, right? So we can do like arrival or target buses equals to set. So we can maybe put that here at the top. And when we're actually filtering over every single stop, we can do like if stop equals target. Then we can do target buses bus, right? So this target buses will contain a set of all the buses that like go through the final destination. So it like suffices to say that if we ever get on a bus that's in target buses, then it means like we'll reach our destination for sure. Okay. And yeah, and we don't need to account for like if we're on the same bus, you know, the number of stops a one bus goes to, that's not like, we're not changing buses, so we don't necessarily need to worry about that there. Okay, let's see. So what we can do now is, I think we might as well just try and do like a DFS or like the BFS here, because I think a BFS ultimately is like going to be necessary. Yeah, we can code out the BFS. Let's see, and then we can maybe just like, if like my solution doesn't work, we can like, I don't know, maybe like analyze some of the field test cases or something. That sounds okay. Okay. Yeah, we can do Q equals dec, where in this case we have, does it take in a list? It does. So we can take in our, I guess, initial position will be source. Let's see. Yeah, so our initial Q, this will be sort of the initial bus that we are on. And yeah, okay, so let's see. So bus to, so this will be the initial, like, oh, I see, bus to stops. We need to first sort of figure out, like, so we're on bus stop source. Let's see. I did have a, okay. We also want, essentially, for every single, yeah, so, okay, this is kind of complicated. So we have buses graph, but we also want for, I guess it's, how do we do this, dude? Okay. Let's just do, in this case, it'll be source, and then it will be 0, because that's like the number of moves so far. So we can do while Q, our current, like, location, and then num, let's see, num, like, stops will be Q dot, like, pop left, or this would be, should be num, like, buses that we took will be Q dot pop left. And then we can do if, like, current, if location in visited, we can continue. Else we can do visited dot add per location. And wait, let's see. And what we want to do here is we can first see if cur location is in what we define to be our, let's see, target buses. Then if this is the case, then we can just return the like number of buses that we took, and this would be correct. If it is not the case, then what we can do is we have a graph of all like the buses of all the neighboring like buses we can take. Let's see. Okay. Yeah, it's like kind of confusing.
I see.
Wait, were you saying something?
No, it's making sense. I think you're going the right
Okay.
direction.
Yeah, so we have, again, the current location, we have the number of stops, and then if our current location is, in fact, visited, yeah, we continue, this is standard BFS. If it's in the target buses, and again, target buses is just going to be like the buses that frequent or that in the target stop. So if current location is in target buses, then we just return the number of buses we took to get here. Else, what we need to just kind of iterate over the entire like neighboring for our current look, like our we need to basically we have buses graph bus. It's like kind of complicated. Let me think. So we have all these other. So we have bus to all the stops. We have the bus to all the stops. Wait, let me just do buses graph does contains a graph mapping like bus to all the stops. So I think so we have this, which is correct. Which so buses graph essentially maps every single like yeah, it'd be well, no, it should be all the buses. Oh wait, I'm like low-key confusing myself here. Wait, target buses. Wait, let me just like step back for 1 second and think. Okay. So from the top, so bus to stops, we have 1020 stop equals target buses. Okay, and then the buses graph, and then for bus, and then for stops for bus, first stop. We do bus to stops. I don't know if this extend like bus to stop is correct, because we want a map from like
Try
bus
printing it
to
out.
bus.
Yeah, you want to see like from this bus, what other buses can we get to, right? That's kind of what you're trying to check.
Yeah. Let's print it out real quick.
Yeah, print it out.
Default list.
So yeah.
Okay, 0, 0, 0, 0. Okay, 1. Yeah, this like doesn't necessarily seem correct. Okay, wait. So stops for bus equals to routes bus, and then for stop and stops for bus, we do buses to stop. Stop, we append the bus. So okay, bus to oh yeah, this is like wrong. This would be yeah. This is wait. Yeah, this is like the naming is like not correct. This should be because I'm doing bus to stops dot append bus, but this should be like stops to bus stop dot append bus, if that makes sense. Okay. So we have stops to bus stop dot append bus, and if stop equals target, we do target buses dot add. Okay, got it. And then bus graph extend stops to bus stop. Okay, so now so this let me run this. Like the graph at least like should be so wait 0. Let's see. So 0, and this is going to be so target buses. Yeah, like my brain is low-key fried. I can't even see where my print name is. Okay, wait, print buses graph. So we have in this case bus stops the bus. So this is like all the buses it can go through. Okay, I think this like kind of makes sense. So 0 and 1, 1 to 0. This is maybe correct. I think because we have so many duplicates, we need to have a set. So what we can do is we can have buses graph set equals to let's see, another default dict. And we can do for let's see, for like key in our buses graph, we can just do buses graph set key equals to set buses graph. Okay, wait, I think I'm like nearly there. Wait, 3 minutes? Okay, I think I can like maybe clutch this out. Okay,
Clutch it out. We can go like 2 minutes over. You're the last
okay, I'll
person.
print this. Oh, okay, yeah, I have that advantage, I suppose. Okay, this looks good. So 0, the actual set maps the buses properly. So it was like a naming thing that was like incorrect, if that makes sense. So, okay, let's see here. We have, so source, we can do, okay, location. Yeah, so again, we can just do source. So this is our kind of going to be like our current location. And over here, right, this can be our current bus, so to speak. So we can instead do sort of like cur bus. And what we can do is we can actually create a manual mapping here. So we can just do, for instance, like buses graph set. This shouldn't be source, it'd be like the source bus, but we can manually set this to be our actual sort of, it won't be our hash map, it'd be stops to bus, negative, let's see, it would be, what would it be? Of our source, right? Because it says stops to bus, so source. And this can be set in a set. Okay, and yeah, so then we can return the number of buses. Else, what we can do is we have all of our neighbors inside of our, like we can essentially use this buses graph set to get all the neighboring buses, right? Because it's in a set. So what we can do is for bus or neighboring bus inside all of our, I guess it's called buses graph set.
I see.
And yeah, it'd be cur bus. Then what we can do is we can just do our regular DFS where we do the actual neighboring bus and then the current number of buses we've taken so far, like +1. And then if it doesn't work, we can just like return -1. I think is it guaranteed? I'm not entirely sure.
No, it says return -1 if it's not there.
Oh, so return -1. Okay. Okay. This needs to be current bus. Oh, okay. Wait. Let me change all of this. Okay. Visited. Wait. Visited isn't defined. Oh, I commented this out. Hold on.
When are you adding to visited?
Here, right after we do the check. Okay. Target buses for neighboring buses. We can just do the neighboring buses. Num buses +1. Let me think. Wait, this seems like fine, I think. Visit equals set, print. We do cur bus num buses equals q dot pop left. If it's in visited, we continue, else we add the current bus. If it's in the target buses, yeah, we return num buses. And then if it's in, yeah, then we just loop through all the neighboring buses in here. Wait, let me just, we already printed this, so this should be fine.
Why don't we throw in the queue all of the buses? Or all of the, or wait, go ahead.
Yeah, I'm kind of like doing, like this is kind of like the issue, like in the queue, like I kind of did this -1 where it pops out. It's like kind of a hack where like this -1, it basically just has all the buses that go to this like source, right?
Yeah.
So it should still work, I think. Wait. Yep. Let me like. Okay, how much time do we have? Oh, we have like. Okay, just give me like 2 minutes. Let's like attach a debugger or something. No, there's no debugger here. It doesn't seem. Okay, it's fine. Okay, we could print it out. Let's do print q. Okay.
Well, the
so-
the
okay,
source isn't always 0. Let's see, case 1.
The source isn't always 0.
Wait, what's here? What are you saying here?
Well, this is the number of like Q. This is going to be the actual like source bus that we've manually put here.
Okay.
And then this is like the number of moves, which is going to be 0. But like I can't yeah, I'm not entirely sure which part of this like we're doing incorrectly, if that makes sense. This all seems fine to me. This actual like bus we extend stop to bus is also fine. Okay, target buses, we add the bus. Wait, what is the actual error? So output -1, but we expected 2.
Yeah.
Okay, let's see. So return num bus. Is it just returning here? Num buses 0, output -1, but expected 2. So it never actually. Oh,
Return.
bruh, it should be is in target buses. I just had is. Wait, this might. Oh, what?
In,
Okay. Dude, is in. Dude, that's crazy. Okay. Let's see. Okay, is it?
Output limit exceeded.
Maybe it's the prints. Well, let me remove this print as well. I should have commented out, but it's fine. Nice. Okay. I mean, it's
Did it
like n
pass?
squared, but yeah.
Where's the print? Where's the print?
I removed it.
Let's go. Pass. Nice. Good work.
Dude.
Only 3 minutes over. Not bad.
Yeah,
For a
it's
hard
good.
question too. Farzan.
Yeah.
Good job, man. Good job. How do you feel? That was a
Bruh,
good one, huh?
I mean, I should have gotten this quicker. I think this is like kind of trippy, just because like you had to, like, convert it the other way, right? You're given, like, each bus has many stops, but you need to convert it for each stop the many buses that go through it, if that makes sense.
Yeah, it's trippy. Like you have to DFS on the buses. So like.
Yeah. But is that intended solution? Do you know, or?
No, yeah, that's a similar solution to what I had. I don't know what the.
Yeah.
I don't want to click on the solution, but let me check.
That's fine. Yeah. Wait. Feedback. I mean, I know it's like not. You know, do you have any? What's the feedback?
Bro, I was just zoning out.
Oh.
I don't know. You did good. You solved it. Here, I posted my solution. Let's see.
You DFS, dude. Oh.
No, I didn't DFS. I don't think I did.
Okay. Bro, what's chat saying? I don't know.
Bro, what's chat saying? I don't even know. They were wondering what you're doing too.
No,
I think
bro.
we had a similar thing. Ours is similar, right?
Yeah, but
So I
yours is
think-
much cleaner though. But the set is like, yeah. I think it's like roughly similar. Len Q, the BFS, route. I think so. Yeah, I think it's like pretty similar to be honest. Yeah. Wait, so
Hell
how are you
yeah.
gonna celebrate? Hey, man.
Bro, I don't know. I'm going back to Canada. I might hit the club or something. We'll see. Might do another
Nice.
another
Bro, I gotta ship
club
to my
night.
tower or something, man. Like,
Oh yeah, I gotta come through. I'll hit you up.
Yeah, for sure.
Yeah.
Sounds good.
Farzan, appreciate it. Thanks for hopping on. You're gonna whenever you're switching or something, or we could talk about other stuff too, like how you're gonna get a promo in a year or something. But we gotta get you up on.
We should do like a career series, dude. Ramping.
Yeah.
You should like mentor somebody throughout their career. That'd be nuts. But yeah.
That'd be crazy. Yeah, we
all
should
right.
talk about that. All right,
Have a
man.
good one. Bye.
See ya. Jan, what's up? Holy, my neck hurts. Yeah, I just want a vibe code too. Yo, thanks everyone for hopping on. Celebrate the 50K. We just hit 50K. That's crazy. Everyone came through, did their thing. We're gonna keep doing more streams. More elite code maybe. I don't know. We'll see. What should I do? What should I do content on? Should I just actually do real coding or just... I don't even know. I have to think about it. Or keep spamming lead code. People like the lead code, but people also like some of the vibe coding. Those videos did good too. IRL basketball content. I'm down. I'm washed though. Y'all want me to keep Side project tutorial. Okay, bet. I'll just keep making videos on random stuff I'm working on. And then when I apply for YC, I'm gonna document that too. I'm gonna try to get into YC. I think that's gonna be the next series. Yeah, I'll do career ones too. We'll figure it out. We'll figure it out. Like how to get promos. Okay, yeah, Farzan, we could just talk on the. We should do that too. We could just do like a group call, where we just talk about how to get promoed up. Bro, it's just straight like from going from 1 to 2 is just straight coding. Just pump out as much projects and features as you possibly can to get to from 1 to 2. But yo, thanks for everyone hopping in. I'm gonna go eat some food. I might go for some Korean food. Yeah, it's just straight code volume. Yeah, we should definitely talk about that. I'll think about that. I'll start thinking about all the. And also, you should also set expectations with your manager on what it takes to get promoted and stuff. Like I remember in my first days in all my company, I say, what does it take to get to the next level, right away, and set the expectation. But yo, thanks everyone for tuning in. Thanks for everyone for hopping in the chat and bodying some questions. That was good. I'm gonna drop a whole. This is dropping as a separate video too. It's like all the OGs hopped on. Farzan, appreciate it. Thanks for everyone for hopping on a Tuesday. Damn, the week is just starting. That's crazy. All right, catch y'all in the next stream. Have a good week.